We're live. Cool. So, yeah, sorry about not streaming yesterday. I got a job, so that's cool. And I'll be able to stream today, tomorrow, and Tuesday, though. Yeah, let's just get into it. Bridges and fillings. Divide the grid into polyominoes so that polyominoes of the same size don't share an edge. Each cell contains a number equal to its polyomino size. For each line, one circle contains an odd number and the other an even. The odd circle gives the amount of odd numbers on the line, excluding itself, while the even circle gives the amount of even numbers, excluding itself. If an odd number is in a cell with an arrow, it gives the amount of odd numbers in that direction. Okay? And if the number is even in an arrow, it gives the amount of even numbers, excluding itself. So, what this means is that, say this line is made up of 1, 2, and 3. That means that one of these would be a 2, because it's counting two odd numbers. And one of them would be a 1, because it's counting one even number. And for these arrows, say that you had a 1, 2, and a 7. And this, well, this one won't work, but say you had a 2, 3, or a 4. 2, 3, and 4 all on the diagonal. This number would then either be a 2, because it's counting two even numbers, or a 1, because it's counting one odd number. Okay? Cool. Let's get into it. The first thing I saw was this one, because this only sees one number over here, so it has to be 1, and this one has to be odd. Three, 5, 7, 9, or X. It could be there. This doesn't say anything about numbers being less than 9, so you can have anything more than 9 as well. This one is at max 3, so same as this one, same as that one. This one's at max 4, 6, 8, and 7. So those I'm not going to count. Okay, but this, one thing I know about these, actually, hold on. One circle contains an odd number and the other an even. The odd circle gives the amount of odd numbers on the line, excluding itself, while the even circle gives the amount of even numbers, excluding itself. Okay, so my example there was kind of wrong. Say this was 2, 3, 4. Then this one would be the even numbers, counting 3 evens, 2, 2, and 4. This would be the odd numbers, counting 2 odds, 3 and 3. That would be a correct example for that line. This sees 4, at most 4, so these ones have to be at most 4. If this, they could not be at 4 though, because if this was a 4, that means all of these. No, that could work. If this were a 4, it'd be counting 4 odd numbers, and this would be 1 counting 1 even number. So that could work. And I believe that these ones will add up to 5. I don't see any other possibility for that. These could both be odd. These could be 1 and 3. counting 3 evens over here and 1 odd over there, for example. This is at most 4. If this were 3, these would all be odd. If this were 2, they'd be 2 evens and 1 odd. If this were 1, they'd be 1 odd and 2 evens. So either it's all odd or 2 evens and 1 odd. Same for all these that have 1, 2, 3. Oh, these ones have to be odd and even. Right. And the odd circle gives the amount of odd numbers on the line, while the even circle gives the amount of even numbers on the line. So they cannot count the other circle. Okay. Yeah, and I knew I was reading that wrong. So one of these has to be even, one of these has to be odd. Same for like these as well. And because, say this is even and that's odd, this is going to count all the even numbers besides itself. And because it cannot count the other one, because that one's odd, it has to only count up to the amount that's on the line between them. So basically what this is saying is that excluding the edge cases, these ones are going to count the number of odd and even numbers on the line between them. So these are at most 3. We do know that one of them, yeah, it cannot be a 3 though. The one of them, this one, the odd one, whatever the odd one is, cannot be a 3. Otherwise, there'd be 3 odds on the line and there'd be 0 evens. But you cannot have 0 in a Flomino puzzle. So this is 1, 2. Same for this. And yeah, now that this is the same rule set that I'm used to, what we know about lines is that these two numbers, the two numbers in the circles, are going to add up to whatever is the amount of numbers on the line, the amount of line segments that there are. So these two numbers are going to equal 1, 2, 3, 4, 5. 5. They have to add up to 5. It's either 1, 4, or 2, 3. Does this one have to be even? Yes. So there are 2 evens on this line. No, not necessarily. You could have a 2 and then the 2 will escape somewhere over here. But that could be the case. What can this be? First of all, these both are the same thing. Because this is either odd or even. This one will be the opposite. So if this was odd, this would be even. And this one would be odd again. So these are the same polarity. Polarity being a odd or even in this case. If these were both 1, then this one would have to be a 2 to join up to that one. If these were both 2, and this was a 1, this one couldn't be a 1, but it can't join up to either of these 2s, otherwise there would be a region of size 3 with 2 cells. You gotta have 2 over here, but this one needs to be at least 3. or you'd have a 2 region that was 3 big, which is not possible. So these are 1, this is a 2, and that's a 2. Now, this, if it were even, cannot be a 2, so it would have to be at least a 4, which means it would have to take at least that one. So this one is always even. And now this one cannot be odd, otherwise it would have to be only a 1. It couldn't escape this way. So that's even as well. This is an odd. This is at least a 4, so it grows to at least there. This now has an even on it. So it cannot, oh no, it can. It can't be a 3. Otherwise all of these would be odd, and that breaks that one. So either it is 1 odd and 2 even, or 1 odd and 2 even. Because 1 counts 1 odd, 2 even counts 2 even. So it's always 1 odd, 2 even. So this is at least 6. This one can still be a 1, could even be a 3 though. If this were even, it'd be the last even on that line. So it'd have to be at least 4. It would have to go here, so it'd have to be exactly 4. 1, 2, 3, 4, 5. There are 5 digits on this line. And there's 1 odd over here, so this one has to be 4. 1, 2, 3, 4, 5, 6. This goes with these there. This one is a 1 now. This one has to escape to at least here, because if it doesn't take that cell, it has to go this way, and then it takes all 3 of these cells being even. There's only 2 even cells on this line. So that's a 4. This one can be a 4. 1, 2, 3, 4, 5. No, this one has to be a 1, because these add up to 5. That's a 1, odd, which makes this a 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. This has to add up to 8. No, this one can't turn into that one. This one has to grow over here. This is 3 or more. This one can't be odd. This has to grow to here as well. 1, 2, 3, 4, 5. There are 5 digits over here on this line, so these have to add up to 5. This one therefore cannot be a 5. This would be a 0. And there are no 0 philomenoes in this grid or anywhere, because how can you fill a size 0 philomeno if you already have 1 cell in it? This one's even now. This cannot be odd, unless there be 2 odds in this direction. So that's be 1, 2, 3, 4. It has to be a 4. This one can also be a 4, or it could be a 2. No, this one has to be a 2 in fact, because these add up to 5 again. This 2 goes over here, which pens this in, makes this a 6. This is 1 or 2. Can't be a 2, this is looking at a 2, so it's a 1. That's the only odd digit on this line, so the rest are even. This one's a 2. There are no more even digits on this line. There are 2, so these 2 are odd. This 4 goes over here now, and it has to do that. This one is even, and so it has to be a 2. This one can't go up there, else it would touch another 2. Another region size 2. This one has to grow, so at least 4. Which makes this one even, which makes this one over here odd. 1, 2, 3, 4, 5, 6, 7. This is 1 or 3, this is 4 or 6. This 8 has to go down over here. This 4 has to grow 2 of these there. Because the most it can take is 1 of these. And it can't get past. Oh wait, it could do that. Never mind. It could do that. But it can't. This one can't be odd. Because it would need to be at least 3, because it can't be a 1, such another one over here. And then it would go over here, and there's 2 odds on this line. There's only 1 on the line. So this one's even, this one's odd. So the 4 does have to grow 2 of these there. This one has to be at least 3, so it cannot go here. If it went here, that would be the only odd digit on this line. And then it would be penned in, and it could be at max 2, but it has to be at least 3. So this one goes here, these 2 are odd, this one grows 2 of these there. Sorry, these 2 are even, this has to go 2 of these there. This one now has to be a 4, which completes this. This one could be a 2, or it could grow. This is at least a 6. It's touching a 2 and a 4. One of these is at least 5, but both of them can be at least 5. We can have... No, this one could be a 3, this one could be a 1, never mind. This one is either a 1 or more. Can't be a 3 though. What is this? This one can be odd if it's a 3. It could be even. 1, 2, 3, 4, 5. No, it can't be even, because there are 5 even cells over here. So this is a 3. This 8 now, 1, 2, 3, 4, 5, 6, 7, 8, has to take at least those cells. This 3 has to grow over here. One, two, three, four, 5, 6, 7. Not sure. The even is at least 3. So the even has to be at least 4. This is at least 3, so it has to be this one takes 2 cells, so the even has to be at least 3. 3 and 4 makes up that. The even is 4, the odd is 3. If this were a 4, it would only take these 4 cells, because these are odd. And then you have 2 odd cells adding up to 2, which can only be 1, 1. But then that would break it. So this has to be a 3. This would have to be a 4. This is odd. 1, 2, 3, 4, 5, 6, 7, 8. This one has to take at least that one. This one cannot go there. So that can't take all of those. 1, 2, 3, 4, 5, 6, 7, 8 has to take at least that one as well. These are all 4 cells that are even on that line, so this is odd. This one has to be the last 3. 4 has to grow here. Have you never? This one can't be odd because there's only 2 odds over here, so it has to be even, counted 2 evens. Yeah, Philomeno isn't that popular outside of variants. Well, you have to like puzzles to like Philomeno, and I only experienced it through variant Sudoku. This is either a 1 or a 5 or more. This one can't be a 5. 1, 2, 3, 4, 5. It would box in that 3. So this is 1. Nah, I've never made a Sudoku myself. I'm not smart enough for that. Whatever this one takes, it either leaves behind a 2, or a 2, or an 8. Or it could leave a 1 and an 8. I just I just don't have the skill set right now to make a Sudoku. I also realized that I pronounce Sudoku weird. That has to be a 1 now. It can't grow here because it have to be at least 3, but then it's touching a 3 over here. So this one is a 3. This is a 4. That's a 4 then. Because this one's at least 6, this has to go to at least there. That's a 4. 1, 2, 3, 4, 5, 6, 7. This one has to be a 3. This one can be a 4, or it can be part of this at least 6. What's this? 1, 2, 3. It's 3 or 5 or 2. 2, 3, or 5. This one can even do just 1, 2, 3, 4, 5, 6, 4 or 6. And if it's odd, then it's 1 or 3. 3, 4, or 6. One of those is a 3. This is either 2 or 3. So either 3 goes here, or it goes down here, and that's a 2. This is 1, 2, or 8. This is 1, 3, 2, or 8. Hmm. 1, 2, 3, 4, 5, 6, 7. This were a 4. Then this would be 1 or 3. This one could be a 3 if this were a 6. Ah, 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 ah. 1, 2, yeah. If this were anything more than 4, it has to be 6. 1, 2, 3, 4, 5, 6, because it cannot, once it passes through this, it cannot pass through this cell, because those have to be opposite parity. So it'd have to go here, and then that is a 6, because that has to be, that's the highest this can be. Which makes this 1, 2, 3, 4, 5, 6. Makes these two have to be even as well. And then there are 2 evens over here. So this is 2 or 4. You should make a sudoku. I'd do it. Sets up to 5. So does this. This is 4, 6x. The dogs in the backgrounds. Yes. Charles just casually solving the collapse conjecture. Actually, I think there are some collapse conjecture related puzzles. Where does 3 go? It can't go here. Yeah. So this 3 has to go here. Otherwise, it'd be penned in and touch another 3 over here. So that's the 3. The 3's can't touch each other. That's something. This one takes 1 more 3 either here or here. If it went here, then that'd be the 4. If it went there, then that'd be 2. This one's never 4 at least. That's how I'm learning from that. Because either the 3 goes here, and the 4 ends here, making this unable to be a 4, touching another 4. Or the 3 goes here, making that a 2. This is never a 4. Which means this is never a 1. Why does this dog bark so loud? It's a high-pitched bark too. We're potty training her, so she what's it called? She stays in a cage for now because she's still like 3 months old, and she keeps on peeing inside the house and pooping inside the house. So we're trying to potty train her by putting her in a cage until she has to go outside. Yeah, we we found her like in the snow during the winter because someone just left her out there. Yeah, humans are terrible. Glad I'm not one of them. One of those is a 2, one of those is a 3. What am I missing? Can this 8 go here? What if this is a 3? 1, 2, 3, 4, 5, 6, 7, 8. Is all those a 4? Oh, that doesn't work. Okay. This one's a bit complicated to see. But if this were a 3 going down here, that would force this 8 to go all the way over here, forcing this 4 to complete, and this 3 to complete, which would make that a 2 over here. But then, how many even cells do you have on this line? 1, 2, and 3. But that contradicts the 2, only 2 even cells. Therefore, this 3 cannot go there, it has to go there. And by that logic, this 8 cannot go here. It has to go to at least there. Still could go over here though. This one is either a 1 or an 8. Oh, this could be a 1 as well. Whoops. 1, 3, 4, 6. If this is a 3 over here, that makes that a 2. Which has to take one of these cells. Which means we have one of the 2 even numbers on that line. We only have one more. That would make this thing... I could do that. Oh, oh no, oh no, oh no, oh. If this one doesn't, if this one goes here, over here, this 4 has to go to at least there. That's 1, 2, 3, 4 even digits on that line, which means both these have to be odd. That 4 is forced to complete. I think this is it. This is at least 6. It has to take at least 3 cells in this direction over here. Or over here. We know that there is at least 3 evens over here. Where does this 6 escape? And this 2 as well. This 2 is taking one of them. So there are only 2 more evens that can fit over here. Which means the 6, because it has to have at least 3 more cells, has to only take 2 of these cells before getting out. So it could go here, and then there. Or it could go here and there. Or here and there. Either way, it's never going to take this cell over here. So this one's always odd. You can have this as an arrangement of odd even cells, this, this, or this. Those are all the arrangement of even cells in this line. But yeah, because she's in the cage, she she just does not want to be in there, and she keeps on barking. Usually, though, she'll only bark if the other dog isn't there with her. The other dog doesn't go into the cage with her, but if they're not in the same room, then she doesn't like being alone. Wait a minute, this thing could do that. Making this able to do that, so this one could still be a 4. Now it doesn't surprise me. I'm also a cat person. Cats are far superior. That's why I like my dogs when they're cats. They might. They're far quieter, far more chill, and they're cuter, and they feel better in your hands when you pet them. The great thing about these dogs is that they're basically cats. The only bad thing is that they're loud. They're loud cats. What else? Can this really be 4? If this were a 4, this would be a 3, an odd 3, which would make this one have to be at least a 5. 1, 2, 3, 4, 5. All of these would be odd, would be a 3. These would be even, would be a 4. This one could be a 4 because it's touching it 4 over here, so it would have to be a 3. Going up to that one. And I don't really see any problem with that. We know that that would be a 2, this would be at least a 6. Over here. That works exceptionally well. What number can this be? It could be a 1. It can't be a 2, otherwise this one is also 2, penned in, and the same as that one. It could be a 3 if it went there. It could be a 4. Cannot be a 5. Could be a 6. Can't be anything more. No, it can't be a 6. If this were a 6, it would join up to here, and then these will all be even, and that would, there'd be 2 evens on the lines. That's not a 6. This is 1, 3, or 4. Pass a 1, 1, 2, 3, 4, 5, 6, 7. Yeah, this is either a 6, a 4, or a 3. The only way that this could be a 3, if this is 1, then that would be a 6. That'd be a 3, that'd be a 2. If this were anything more than 3, it would have to do that. If this were a 6, it could do this. Or even that, but, you know. I'm a little bit stuck on this puzzle. Not sure where to go next. So it looks like it wants to be tidal wave from here to here. As in when I started here and I go to left. If this were a 1, this one would either have to be a 1, making all those even, as well as that. Or it would be a 4. Breaking down to 3. Okay, so this one, yeah, this one would have to be a 1, not a 4. Because if this is a 1, it's counting one even odd cell over here. All those have to be even. If this is 1 or 6, then these are both even. If it's 3 or 4, these are both odd. So this one can't be a 4. That's what that's saying. Because if this were a 4, these would both be odd. That would be a 3, that would be a 4. This 4 has to go over here. Oh wait, no, that could be a 2, that could be a 4. Never mind. Never mind. But that one does have to be a 3 though. Those have to be a 4. This is an odd. Yeah, that doesn't say anything. Am I missing any arrows? Or perhaps any lines? This arrow's pointing right. I got it. This arrow's pointing up. I got it. This arrow's pointing this way. I got them. This arrow's pointing up. I got them. Oh, this is wrong. What? What? Did I place that in? Yeah, because the rest of these have to be odd. Or even, I mean, because this one's odd. There's only one odd cell on that line. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So that is correct. That one definitely does have to go there. So it went wrong when I did the logic on the 8s then. Let's see if this logic is good. That one definitely has to go out to the 8s. That one, 1, 2, 3, 4, 5. It can't be the evens because it's counting 5, so it has to be odd 3. This even 1, 2, 3, 4, 5, 6, 7, 8 has to go to these there. I'll just go there. There are 3 evens, there has to be at least 4 evens. 2 odds means there has to be at least 3 odds. 4 and 3 counts to be under things on the line. That's correct. That one couldn't be a 3 because a 4 because then this would be penned in. There'd have to be 2 1s. 8 doesn't have to go to at least there. Because yet again, it can't take all of those cells. In fact, from here we know that this one has to be 2 evens. This one has to be odd. Which means 8 has to go to at least here. This 3 has to end there. This 2 has to end here. This 4 has to go to at least there. This one definitely can't go that way, whether it's 3 or 1. One, two, three, 4. There are 4 on that line, so this one has to be even, so it's a 1. Sorry, odd, so it's a 1. So this one is 3. 1, 2, 3, 4, 5, 6, 7 has to end here. 8. Probably what I did is that maybe this one doesn't have to be 3. Maybe. Maybe this could be a 6 and go there. That's also probably the case. Okay. 4 has to go into one of those two. So that's not a 4. These are 1, 2, 3, and 4, though. If this were a 4, have to do that, because I can't touch that 4. Now it'd work. Or 2, those all have to be odds. 3 there. There are 3 odds on this line, so this one is a 4. And all the evens are on that line, so these have to be 3 odds. The 4 ends here, therefore. And this is a 2, 3 pair. This one isn't a 5 or more because it boxed that one in, so this one has to be a 1. This one therefore has to be a 3. Either it ends there and this is broken, or it ends there. This is a 2. If this were a 3, there are 2 evens in this line, so this is odd, which means this one is a 3, because it can't be a 2 or into an odd. So we have 2, 3, these 3's finish there. The 2 has to finish here. This could be a 1, or it could be more, it could be 5. 1, 2, 3, 4. No, this one has to be 1, 2, 3, or 4. So this one has to be a 1, because it can't be a 3, and it can't be more than 5. This is not a 1, this is not a 4, these are not 2, 3, so this one is a 1, 4 like that. This is odd, this is even. It has to come to at least there. Those are 4. 1, 2, 3, 4, 5, 6, 7. This could still be 3 and now work. 3, 1, 3. This 6x goes to here. At least 6 goes to there. Which means this one can't, no, this one, what is this? Can't be 2 odds, has to be 2 evens. So this 4 can't join to at least a 6, so it has to come over here, which means this one is a 3. This one now has to be a 4 to complete that 4 region. This 3, in order to fit over here, cannot go there, otherwise we touch another 3 region. So it has to end there. This one is a 1. This is a 3. This is a 2. This success has to go to at least there. These are 4 even digits on this line, so these rest have to be odd. 2 is finished. This at least 6 has to go here now, making this an odd, that an even. This now has to be 2. This at least is 6, but there are 1, 2, 3, 4, 5, 6, 7 on this line, so this one has to be at most of 6 now. That's a 1. This is a 3. This 6 now has to finish either here or here. 1, 2, 3, 4, 5, 6, which means it cannot, this one cannot be a 6 arrow, it has to be a 1 arrow. This is the only even digit on this line, so there are the odd digits on this line, so these are all even. Which means this one can't be a 2, has to be a 6. It finishes that. This one is either a 2 or 1, 2, 3, 4, 5. 2 or 5. Which means this 4 finishes here. This 3 finishes there. This is a 2 or a 5. If it's a 5, it goes here. And then this line is broken because there has to be only one odd cell on this line. So that's a 2, making that even. Oh, also because this is even. It's just 4 odds. But there are now 4 evens on this line, so this one's odd. This is a 2, completing that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There has to be at least one more that goes there. These 2 are odds ones. And there are 1, 2, 3, 4, 5, 6. Cannot be a 6 itself, or we're touching another 6. So this is either, this has to be 2, 4 in fact. Because they have to be even. These 2 are 4. This is a 4 now, that's a 4, this is a 2. There we go. Not too hard. A 4-star puzzle, I would say. But it's only because I missed the logic here. Honestly, it's probably more like a 3-star puzzle. Alright, time for a 5-star puzzle. This one looks like it's probably going to be at least 2 hours long. Poggers, thank you, thank you. Oh no. It's a loop cell. Loop puzzle. A third loop. Fill some cells in the grid with the digits 1 through 9, such that no digit repeats in a row or column. Tapa-like loop. Draw an orthogonally connected, non-intersecting loop at the centers of some cells. Question marks and given digits are tapa-like loop clues. These clues cannot be on the loop, and they represent the number of consecutive cells occupied by the loop each time it enters the up to 8 cells surrounding the clue. If there are 2 clues in a cell, each clue corresponds to separate loop segments. Cells in this loop contain no digits. Gotcha. Every cell with 2 given TLL clues contains 2 digits each. All other cells in the grid contain 1 digit each. Regions. A region is an orthogonally connected collection of non-loop cells. Okay, digits cannot repeat within a region, and regions cannot touch each other orthogonally. Region sum lines. The red and blue lines are region sum lines. Numbers on a line have the same sum in each region the line is in. If a line passes through a region multiple times, each individual segment sums separately. Some clarifications. Given digits, i.e. TLL clues, cannot repeat in a row, column, or region. A question mark represents any of the digits 1 through 9, and therefore a question mark's value cannot repeat in a row, column, or region either. Also note, for answer check to trigger, exclude any digits from cells containing 2 TLL clues. Okay? So, Tappa, we did this before, I believe 3 days ago, where instead of loop those shaded cells, and it was with the Schrodinger cells. So if this were 2, 3 in there, then it would say like there's a consecutive segment of 2 over here, of 2 shaded cells over here, and a consecutive set of 3 shaded cells either here or here. Again, it doesn't matter where it is. But that's what that'd be saying. There's a consecutive set of 2, there has to be space then between the next consecutive set, which is 3, and they cannot touch each other. Do the question marks have to be the same? No, in fact, they cannot be, because a question mark's value cannot repeat in a row, column, or region, which means that these two cells, which occupy the same cell, are parts of the same row or column or region. Well, actually all of them. Let us do green for region cells, and I'll do shaded for loop cells. Five. 1, 2, 3, 4, 5. Yes. Okay. Can question marks be 0? No. From 1 to 9. Yeah. Okay. So this means that this one has to either do this, 5 and 1, or like this, 1, 2, 3, 4, 5 and 1. So these are always taken up, as well as all these. These are always loop cells. Wait a minute. Orthogonally connected, non-intersecting loop, whose central system cells. Question marks and given digits are Tappa-like loop. They represent the number of consecutive cells occupied by the loop. Oh, okay. There does not have to be any spaces between these ones. Because it's not saying how many consecutive cells there are. It's saying how many are connected to the same loop segments before it goes out. So therefore, if this was a 2, 3 over here, then this could be a 3 like that, and a 2 like that. We could do that. Okay. That's a little bit less constrained. There are at most 9 green cells in any column, row, or region. That's something to note. How does this one work? 1 or 2? This one cannot be loop, otherwise it would take at least 5 cells. But that's neither of the clues. Therefore, these two cannot be loop either. The 1 clue now has to be this one. Because how else would you get something? How a 1 to enter that loop and exit it without taking another cell in that loop, without taking another cell in this region. This one takes at least that cell. This one takes one of those two cells at least, so that's 2. And the same for those. So this one has to be the only one and does that. The 2 then is either this or this. That's 5. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. It does take at least those cells. And the other, and all of these have to be taken now. Not necessarily. Not necessarily. You could just have something like that. 5 and 1. Or 5 and 1. But the 5 does always take one of these. And these are always taken. Because it's either 1 on one of those, or it's 2 taking that corner. One, two, three, four, five, six, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These are always taken by the loop. Given digits are also tuple legs. This one, which means there's only one of these going around. It's either 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, but it always ends there. And it always exits through here. Which just has to go there. Those both are loop cells now. This one cannot do that. Yeah, because if this did this, then this one is completely cordoned off from being loop cells. And all of these then have to be a region. But how many are in that region now? 10 plus 1 is 11. 11 cells containing digits 1 through 9 is impossible. Bless me, sorry. Which means that this has to be a 5 this way. It also means that these are region cells and these are loop cells. Let's go there. Do regions contain 1 through n? No. They just have to contain no repeating digits. 1, 2, 3, 4, 5, 6. There are only 3 more region cells in this grid, in this row. We also now know that this adds up to at least 15. 1, 2, 3, 4, 5. It's at least 15. So this one now has to take 2 more cells, because 1 more cell would add up to at most 14. So those are all region cells. This one cannot be a loop cell now. We were to escape. would intersect itself. This one has to go here now, which means that it also has to go here now. And that ends that one. This one can still do that, or it can also do that, or it can do that, or that, or that. This one either goes here, or it goes there. Well, this question mark is either a 1 or a 2. This has up to at least 10. This one has to add up to at least 15, so it has to go to at least there. Because this one can be at, well, it's at most 7. So this one is a 1 now. This is 5 and 1, which means this is 6. Which means this one could be a 9 still, and complete 15. This goes to at least here, because if this were loop, then this would have to go to there, and it would have to be added to 15 in 2 cells with a 5 in it. It's possible, there's no 10 cell. So this is unshaded. Now there has to be 5 around here somewhere. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. These are all loop cells. This one now has to go there. This one has to complete there, which means this does that. These two are both unshaded now. They're both region now. This one is a 4. There's only one thing there. So these are not loop. That goes there, that goes there. This one can still go there, because this doesn't have to be 15. In fact, the most this can be is 27. 7, 8, 9 is 24, plus 3 is 27. This is a 6. What if it does, which means it has to take this one. Because if it doesn't, then all of these cells cannot be loop. And it'd only be left with 5. So this has to be part of the loop, it has to do that. And it takes one more cell. That one or that one. So this one is unshaded, this one's not region. One, two, three, four, five, six, 7, 8, 9. These are all the region cells in this row. 2, 4, 5, 6, 2, 4, 5, 6, 7, 8, 9. So these are all loop cells. Makes this a region cell. This one now has to do that. This one has to go here. This one has to do that to go through. This can connect to here if this does that. This one can't skip through there, so it has to do that. This is unshaded. 1, 2, 3, 4, 5, 6, 7, 8. But this one has to have at least one more thing. Since it could go there. This one could even do that. I could do that. This one could go there. And this either does that or it just goes there. So that cell's always taken. One, two, three, four. This one can't go actually because there's a 5. That one has to be a 5 like that. A 5 there and a 1 there. This is a 4 here and a 2 there. 2, 3, and a 1. This is also a 1. This is a 4. This is only 2 cells. It's not 1, 2, or 3. Or 5 or 6. This has to be 7, 8, or 9. So it's at least 15. It's not a 6. This one has to go to at least there now. Because the max it can be is 8s. Max it could add up to is 8s. So this is 7, 8, 9 as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is also like that, does that, this does that. This one has to go here. Oh no, what'd I do? What did I do? This is at least 15. Is this a different line? No, it's not. The blue line is one line. The red line is another. Oh, that's why. Okay, so this one definitely has to complete there. This is unshaded. This one now has to do that. This one has to do that. I'd be blind sometimes. Because this one is a 3, this one now has to be a 4. This one has to go here now. This is 3 and 4. This is 8 or 9. Which means this one is a 15 or 16. Definitely has a 7 in there. This is a 2. This one cannot be a 4. So that's a 4. So it has to go to at least there. So it has to go to at least there. And then we set a 5. 1, 2, 3, 4, 5, 6. Sorry, it has to be a 6. There's only one more unshaded cell in this row. 2 more in this column. Sorry, I'm in column. This is either 3, 4, 5 or 3, 4, 6. This is a 3 or a 4. This is 7, 8, 9. Excuse me. This one cannot be a 3 or a 4. It must be at least a 5. So that one has to go there. This one cannot be shaded because it can't go anywhere over here. Well, it intersect itself. It has to grow to at least here because it's at least 15. In fact, these are the 2 segments over here, which is 1 and 2. So these are all unshaded. 1, 2, 3, 4, 5, 6, 7, 8. This one doesn't go here. Those would have too many cells in the region. This one has one thing over here and over here. So those are the same number. This is a 5-star puzzle? Are you sure about that? Maybe it's just because of how long it is. This one has to come out, it has to escape through here. So this one has to do that. It could take that one or that one. But it can do that, yes. This one is one thing, so it has to go through like that. Oops. Which means that this is a 7 or an 8. It cannot be a 7. Let's just be 17, which is impossible over here. So this is an 8, which makes this, oops, a 7, 9 pair. 16, which makes this 1, 3, 4, 6. 1, 2, 3, 4, 6. I mean, I suppose if this is like your first time to this to loop puzzles, it might be hard, definitely. But like for a MathPesto puzzle, this doesn't seem like 5 stars. I'm I'm already halfway through this and I'm only 20 minutes in. This one has to be a 9. Is that 9? That 7. That an 8. This one can no longer be a loop cell. This one is now 9 cell regions. The rest have to be loop cells. This one has to do that and that. I believe there are 9 cells in this region. 4, 5, 6, 7, 8, 9. Yep, so these are all loop cells. These all have to connect somehow, either like that or like that. And because 1, 2, 3, 4, 5 is at least 5. It can't be a 6 because of that one. It can't be a 9, so it has to be 5, 7, or 8s. This one has to go there because there's only one loop segment in this thing. This one is a 5. So this is no longer 5, this is 7 or 8. If this was region, this would also have to be region. And then you have 5 cells in here that have to add up to 16. But that's impossible because there's a 5 here. 5 cells that add up to 16 is 1, 2, 3, 4, 6. Which means this one has to be a loop cell. This is 1, 2, and 5. Which means what is this adding up to 15? 16, sorry. 3, 4, 6 is 13. Has 2 degrees of freedom. No, 3 degrees of freedom. Which means it has to have a 3 in it. Could be 6, 7. It didn't contain a 4. This 8, where does it go in this region? If it were here, then these two would have to add up to 8s. Which is impossible. It can't be 1, 7, 2, 6, or 3, 5. So this one is the 8s. These two have to add up to 11. It could be 9, 2, 8, 3, 7, 4. That's too many options. 4, 5, 6, 7, 8. There's at max one more in this row. This is always shaded as well as this. Because if this was unshaded, this would be the 7-cell loop consecutive set. And it would have to come out this way, which is impossible. The same for this one. That'd be 7 cells, and it would have to go that way. So these are both loop cells. One or both of these has to take this one. 1, which means it always takes these two. Because if this one was not in the loop, part of any loop, this couldn't be a loop. So you'd have to have two sets of loop cells over here that are not connected to each other. How can you do that? You could have one over here, but then where does that one go? It has to connect to that one. There's only one cell over here. You have one over here, but then again, those are all broken. So yeah, and this symmetrically applies to the same over there. Those are both loop cells. Get it done, get it done, Lore. ちょっとならせ。What is this? If this were a 3, these would have to be at most 4 or 5, which adds up to a 9, which is impossible. So this is either 3, 4, or 3, 5. There has to be a 3 there. These have 2 more adding up to 13, either 4, 9, or 7, 6. Both of those seem to work. But these two now also have to add up to 13. They're either 9, 4, or 7, 6. What's this cell, though? It can't be 9, 4 because there's a 9, 4 looking at it. So it has to be part of the 7, 6, which means this is 3, 4, 9. This is a 6, this is a 7. That's an 8 now, so all of these are shaded. Wait a minute. Oh, yeah, no, that works. This one has to do that. Also, this is a 1. Yeah. This is 5, 7, or 9. These are up to 5. Get it done, get it done, odore. Chotto narase. 4, 5, 6, 7. That could still work. No, no, no. No, no, no. Yes. Okay, yeah, this is impossible. If this went here, it has to take that one, because that's in a new region from that one. Oh, wait. well, it's the same region, but if a line passes through the region multiple times, each individual segment sums separately. So if this went here, it would pass into this region again. So it would have to be different. They would have to be the same sum. So it would have to go to at least there. And now, where does that loop cell go? It can only take one cell, which is impossible. So that one has to be loop, which means this one does this. This one also cannot be region, otherwise I have to do that for the same or similar reasons. So that's part of the loop, so it goes there as well. What can this be? It's not a 1. It could be 2, 3. Can't be 4 or 5. Can't be 6. It could be 7 or 9. So this is 2, 3, 7, or 9. This is at least a 5. It has to be more because it sees a 5. It can't be a 6 either, so it has to be 7, 8, or 8. What am I looking at now? I mean, these are 2, 6, 7, or 8. This is not 6 or 8. It's 2 or 7. Or if this didn't have a 2 in it, these have to add up to at most 5. So this could be 3, 4. It have to have a 1 in it, which would have to be that one. And then you could have a 3 over here. 1, 3. That were a 2. Yes. This one has to be the 3, because it can't go there. Oh wait, yes it can, never mind. It could do that. If it were... This is 1, 2, 3, and 4. 4 being the max, though it could not have a 4 on it. Yeah. It couldn't have a 4 on it. Because say it did that 1, 2, 3, 4. Oh, it would have to be a 1 and we connect to it. So this is 1, 2, or 3. Could be 1, 3, 1, 2, or 2, 3. I wonder why it's called the third loop. What are these cells? One, two, three, four, or five. They cannot be 6, 7, or 8, and they cannot be 9, because there's only 8 cells around them. Don't say. Is there a region that I'm missing? This one. This needs 11 more, which has to be 3 8s or 4 7. It needs 11 more to get 16, which is 3 8 or 4 7. This one as well. This is 16, it's 10 more, which has to be 2 8s. Which means this one is a 1 3, which means it does that and that. This one now has to do that, or that has to do that, because no, I could do that or that. But this one could still be 3 4 5, or this could be 3 4 5. One or both those is taken though. This is region, so this also has to be region. This is 7 9, tab 16. This is not 3 anymore, or 2. That's 7 or 9, which makes a pair there. 9 8 7. This could be 6 4 3 2 or 1, because there's a 4 there and a 5 there. 1 2 3 4 5. 1 2 3 4 5 6 7. At most 2 more in this row. At most 8 more in this row. Also, that doesn't need to go there, because this could do that if it were an 8s. I wonder if I made that mistake somewhere else. Maybe that's why I found it so easy. No, this was justified because of that. Didn't even use that for that. This was also justified because it was coming into this. This was justified because it was coming into this. That was justified because it's coming into that. Yeah, the rest were justified except for that one. get it done, get it done, odore. Chotto narase. Okay. This is not a 2 anymore, in fact it is a 3. Sorry, a 6 I mean, because this is a 7, which means that a 4, which means that an 8. All of those now are shaded. This is no longer a 4. This one could still do that. In which case that does that, and that does that. Get it done, odore. This is 11, can still be 9-2, 8-3, or 7-4. At least one of those has to be taken by a region. Same for at least one of those. It's a little bit constrained. This one could be a 5, or could even be an 8. Or anything in between. But if this goes here, then it is an 8. Ah, this is 1 or 2, which means this one cannot be 1 or 2. This is 3, 4, 5. It has to have a 3 in it. It's not a 3, which means it's not 4, this is a 3, 5, which means all of these are shaded, because that adds up 8. It's always Sudoku. This one has to be part of the 5, which means the other one's part of the 3. I can either go there with the 3 there, or I can go there with the 3 there, but those two are always part of the 3. How many line segments are over here? Line ends, I mean. It's 1, 2, 3. And either 4, 5, 6, or 1, 2, 3, 4, 5, 6. Alternatively, you can also have 1, 2, 3, 4. With nothing there. This could go up there. But you can also have 1, 2, 3, 4. Yeah, 1, 2, 3, 4. With nothing going up there. And just what I'm doing here is that whenever you have an area of the grid that has a limited number of exits, you can count, because this one only has 2 exits out of this area of the grid, you can count how many line segments there are in that region, and the number is going to have to be even, because they are all going to have to join up with each other. And 1 plus another 1 equals 2. So they're always going to be even line segments in any portioned off region of the grid. This is 1, 2, 3, or 4. Cannot be 7, because then if it was 7, it would do 1, 2, 3, 4, 5, 6, 7. And then these two would have to connect, because this one connects to itself. Yes. Because now I have to do that, I have to do that, I have to do that, I have to do that. Connect to yourself. Because those are 2 lines. Those are 2 end lines. And then you have a trivial loop over here, but there's only 1 loop. Only 1 loop in this grid. Yeah, only 1. Okay. What is this? Cannot be 1, 2, or 3. Has to be 4, 6, 7, or 8. These are 2, 3, 4, or 6. This is not 2, 3, or 6. So it has to be a 4. This is a negative single. It can't be 1, 2, 3. or 8. Can be 1, 2, 3, 5, 6, 7, 8, or 9, so it has to be 4. It's a 4 though. No. I did something wrong. It was wrong of me. What did I do wrong? This one is a 4, not a 3. When did I place that in as a 4? As a 3, I mean. Was that a typo? Must have been a typo. But it hasn't affected anything else in the grid. Because it doesn't see anything else that I've placed so far. Yeah, this one is a 2, 4. So this one cannot be 9, 8, 7, 6, 5, 4, 2, or 1, so it has to be 3. And again, this hasn't affected anything else because it doesn't see anything else in this grid that I've done so far. Only things that have affected is up here, but yeah, it hasn't. This is correct because it's 16. Yeah, okay. I am okay with that. This one then is either 2, 4, 5. No, not 5. Or 6. It's not 9, 8, 7. It's not 5. Again, typo. It's not 3 or 1. So it's 2, 4, or 6. It is even. That's neat. Don't know how to say. Um, I don't know. This one is 1, 2, 3, or 4, or 5. 1, 2, 3, 4, or 5 is what I would say. So if that goes there, that goes there, that's a 5. If this So that would go there, and that would go there. If this goes there, that one does that. This goes there. Hmm. If these are all region, they have to be 1, 2, and 8s. Yeah, that's not interesting. Oh, wait, yes it is. Yeah, it is, because this is all part of this line segment. This means I have to add up to 16. Thus, if any one of these are on the line segments, they all have to be. They would all have to add up to 1, 2, and 8, which is 11, which is not enough. So these are all loop cells. Which means that does that. Oops. Which means that has to go there now. Has to do that, has to do that, has to do that now. This one now has to do that. This one has to go there now and complete that. So that goes there. This one has to do that for the 5. This one has to do that for the 3. This one cannot go in there. There's 3 segments in this area. How does the last one escape? It cannot, so it has to do that. This is no longer part of it. And I can either do that or that. Oh, but it cannot enter here again. This is only 2 tap clues here. One of them is that one of them is that one. This one is a 2, so this one has to be a 3. That's not 2 anymore, that's not 9. This one is a 5. That's not a 5 anymore. So this one now goes here, because there can only be 2 tap clues around here. This 5 goes over here. This 2 or 3 has to take at least 1 more cell. So, oh, these ones do have to be this, yeah. These 3 have to add up to 10. No, sorry, 11. So I have to have a 1 in it. And 1, 4, 6. It has to be 1, 4, 6. In fact, there's 5 cells here. It has to be 1, 2, 3, 4, 6. Yeah. This is 2 or 6. That's a 6. This is 1, 4. That's not a 4. Which means that isn't a 7. This is a 3, because the 4 looking at it. That's 4 and 6. This is a 6. That's a 4. This is a 4. That's a 1. Build Sudoku, building this out a little bit. This one cannot be a 1. Either has to be 3, 5, or 2. In fact, this is 3 or 5, so this is 2. So it has to do this now. This is 4 cells, so this has to be a 4. These are now all unshaded. So are these. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's one region, so these all have to be shaded. So these are part of the loop. These ones have to escape like that. This now cannot be a 7, otherwise it has to be 1, 2, 4. So it has to be a 9, which is 1, 3, 5. These are both 9 now. Which means that's a 9, that's a 7. This is a 1, 3, 5 pair. This is 6, 7, 8, 9. 8 does not go there or there. It goes here. 7 does not go here, it just goes there. 6, 9 pair. This one has to do that. Oh, this is a 2 here. This one can be a 3, or 1, 2, 3, 4, 5, 6. It's definitely a 2 though. Ah, this is not an 8, so this one can't do that. It has to go here. This is not a 6. This is just looking at it. Alright, so now that I'm getting stuck, now I can see this probably is a 5-star puzzle. Alright, let's misjudge it by how fast it was going at first, and how smooth it was. Boom, boom, boom. This is 1, 2, 3, or 4, I guess. This one can't be a 5, because then if it by itself on the line. This is 1, 2, 3, or 4. Well, this is at least a 3, so it does go at least there. Same for this going to at least there. Now, 1, 2, 3, 4, 5, 6. This is 6, 7, or 8. It's definitely not an 8, so 6 or 7. If this were a 6, it would do that. That'd be a 7, it would do that. Yes, this one can't be a 6. Otherwise, this would break off all of these, and this would be up by itself. So this one is a 2, 3 pair. And that 3 and that a 5. Yeah, this one has to go do that. This can still be 6 or 7. These are all now part of the regions. This is 1 or 6. Can't be 9, 8, 7, 5, 4, 3, or 2. This is 4, 5, or 7. Looking at the column again. This one has to go here now. What can those numbers be? 2, 4, 5, 6. There are 1, 2, 3, 4, 5, 6, 7. 7 things around them. So it can't be a 6. Could be 2, 4, 2, and 5. But definitely doesn't have a 2 in it. So this is not a 2. Can this go here? I don't think so. Because then this would be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 cells does not adds up to at least 21. Also, one of these is a 2 and this is a 2, 3, so of course it can't. Which means this is loop. This also has to be loop, because either you have 2 and 4, or 2 and 4, or 2 and 5. These 4, this has to, if this did not go here, then this would have to be 2, 3, 6, 5 to add up to 16. which works. If not, and it went here, it'd have to be 1, 2, 3, 4, 6. 6 would still have to go there. And there couldn't be a 1. If this went here, it has 5 cells in this region that have to add up to 16, which has to be 1, 2, 3, 4, 6. But then where does the 1 and 6 go? This is a 1 and that's a 6, both looking at this, which means they both have to go here. That's not a Schrodinger cell. So this one has to be loop, this has to be 6, 5. Get it done. 1, 2, 3, 4, 5, 6. At most 7, so this one's always unshaded. Because this is part of a new segment in the region, it has to go to at least there. Which means this one does this. This one either goes here, and that stays there, or this goes there, and that does that. One, 2, 3, 4, 5, 6, 7. This one can't join to there, otherwise there'd be 10 cells in this region. 2, 4, 5, 6, 7, 8, 9, 10. So that is part of the loop. This is 3 and 5. That does that. That's the 5. That's the 3. It goes there. This one is now a region cell. Has to be a 1. Because you have 9, 8, 7, 6, 5, 4, 3, and 2. This is no longer a 1. This now has to complete the 8 like this. This now does that to get out. This has to go here, otherwise this is way too large of a region. You have 2, 3, 4, 5, 6, 7, 8, 9, 10. So it does that. This is now a 7. 1, 4, 7, 8, 9 left in here. This is not a 9 or a 1. It's 4, 7, or 8. These are not 8 and 1 either. 4, 7, 8, or 9. This is not 6 anymore, it's 2 or 4. There's only one more loose item in here, it has to join to that. This one cannot be part of the loop, otherwise you would have at least 5 cells here, but this is at most 4. This can't be part of the loop because I have to do that. If it's a 4, it does this, but then that would be a 1 over here, which is impossible, it does that. So it isn't a 4, it is a 2. Also, this one has to go to at least there. This is part of the loop now. These have to add up to 14, 9, 5, or 8, 6. Can't be 9, 5. It has to be 8, 6. This is 1, 4, 9, based on Sudoku, because it cannot be 2, 3, 5, 6, 7, or 8, so it has to be 1, 4, 9. This one has 1 and 9 looking at it, so it has to be a 4. Give me a second. Job's calling me. Bruh. Calling me into work again. Saying that it didn't matter that I'm not the reason why they sent me home in the first place. STG. Alright, let's continue. This either does that, then like something like that. Well, this one always has to escape through here. So it does that. It cannot be a 4. Because if it were a 4, it would either have to do that or that. And there's only 2 cells here having to add up to 16. But then the other cell would have to be 12. So this isn't a 4, this is 2 or 3. In fact, it needs 2 more cells to add up to at least 13, with the 3. So those 2 are the cells that it has to take. And this is either a 2 or a 3. Da, 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 do. This would be 109 if it was in this region. What else is left in this region? 19357. 19357. Gotcha. This were 2. This would be 14. Should be 9-5 in any order, or 8-6. Well, 5-9 in that order, or 8-6, because that's 5 looking at it. On the other hand, if this were a 3, this would have to be 13. Which could be 9-4, any order. Could not be 8-5, or 6-7. Yeah, all those work. If this were a 5 in here with a 2, then 1, 2, 3, 4, 5, this would have to be a 1. All of these would be region. And that one could not be, because there's already 8 here, if this were a 1. This one has to grow, obviously. It's part of one of these, so it has to grow, as part of a region cell line. It has to grow to 1 more at least. So this has to be 2, 4. With this being the 4. This is a 6 now, so this has to have 10 more. It has to grow at least 1 more. Could be 1, 9, or 3, 7. In this order, 9, 1, or 7, 3. This have to be 9, 7 in that order if it were part of it. Otherwise, it would do that. The loop. probably what does happen in order to resolve this. 7, 3, with a 4, 8 pair over there. In fact, these are not 8 anymore. It's 4, 7, or 9. This cannot be yes, it can. It could be a 4 like that. Then those two would be taken. No, it cannot. Okay. If this were... Wait, no, yes, it can. I confuse myself sometimes. 5, 3. Yeah, let's definitely have to do that. This has to go there now. What number can this be? Can't be 9 because there's at least 8 cells, at most 8 cells. Can't be 8s, could be a 7. Cannot be 6, 5, 4. Could be a 3, 2. Cannot be a 1. Except for a 1, all of these would be unshaded, then where would this go? It's stuck. If it were 2, it would have to go this way. I'd have to do that. Which is pretty likely. What is that? I know that. Oh, this is a 2 for that one, so this goes there. This is a 1, 9 pair. This is still 2 or 3. This is 3, 5, or 7. Oh, this is a 4 here, so that's not a 4. This is a 1, 3 pairs. This is not a 3. That's 5 or 7. This is not a 4. These two add up to... these are a new thing. These have to be part of the thing. So it has to be 7, 9. A new segment. This is 7, 9. Yeah. This makes that a 4, then a 9. This is a 4. This is an 8. This is 7, 9 pairs. This is a 5. This is an 8 now, because that's the only thing it can be. Can't be 1, 2, 3, or 4. It can be 5, 6, 7, or 9, so this is an 8. 8 needs 8 more. This is either 2, 6, or 3, 5. It can't be 3, 5 because of that 5. This is a 2, 6 pair. This 2 has to go there now. It's a green. This has to go at least there. Can it take 2, 7, 9s possible? Takes 3 or 4. What if it takes 4? If this one does not go here, this one is always like that. If this one does not go here, it's 4 cells that up to 16. Without 2, 6, and 8, is that possible? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's 8 cells. This is 3 and 5, so it's not a 3, 2, or 7. This is either a 2 like that, or it could be like 7 like that, or 7 like that. How does one make 16 in 4 cells? 1, 3. Oh, what are these cells? They cannot be 1, 2, 3. 2, 3, 4, 5, 6, 7, 8, 9. What would this cell be then? Copy 9, 7, 6. Copy 1, 2, 3, 4. It has to be 5. This would be 9 if these two were part of it. If this was part of it. 9 needs 7 more. Which cannot be 1, 6, 2, 5, or 3, 4. This is impossible. Which means this one has to do that. This 4 or 5 needs either 12 or 11 more. 12 would be either 9, 3 or 7, 5. 9, 3 or 7, 5. And 11 cannot be 9, 2, cannot be 8, 3, cannot be 5, 6, would have to be 7, 4. Which could be done like that, 4 or 7. Because that 2, 4 pair there. So this is 7 or 9. Get it done, get it done, dore. Chotto narase. How many cells are left in this column? 2 more. If it were to fill, you can only have 2 more, 1, 2, or 3. If this were 2, that'd be 1, 2, or 3. Ah, yes. That is pretty complicated to see. If this were a 2, this would have to do that. This, well, these all would be, yeah, actually this is not complicated at all to see, because this is a different reason. I'll show you the reason that I saw before, which is much more complicated. But if this were a 2, that would have to do that. These would all then have to be unshaded. And then how many cells were in this region? 10. 7 over here, and 3 over there. Oh, actually 4 over there, because that's 2 cells. And 10 cells is way too, 11 cells is way too much for a region. The way that I saw it before was that this would be shaded. This would have to go here, otherwise this one cell would have to be 16, which is impossible. And then all of these shells would have to be shaded. You couldn't have a loop in here, otherwise they would intersect itself. And then how many cells do you have here? 4, 1, 2, 3, 4, 5, 6, 7, which is 12, which is also impossible. So this one is a 7, which means that's a 9. These two have to then after 7, so it has to be 3, 4. Maybe 1, 2, 3, 5, 3, 4. Also, these are all loop cells. This one has to do that. And the reason why they're all loop cells is because every single digit is in this row. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one, if it went there, would have to do that. Because there are two segments over here, loop segments over here. There cannot be an odd number. So either this one goes here, and that does that, or this goes here, and it does that. Either way, this is always going there, because otherwise, there would be an odd number of segments in this area that cannot escape. 7 always goes there. This one now needs at least 13 more, so it has to take those two. This one is a 3 now. This is 13, either 9, 4, or 7, 6. 9, 4 in that order, or 6, 7 in that order. The only two possible things here are 1 and 3, which is not possible over here, or there. Yeah. 9, 8, 7, 6, 5, 4, 2, 1. Only two numbers left are 1 and 3. And both of them see 1 and 3 in their column. So that has to do that, which can work either like that, or like that. This cell, where does this loop segment go? Over here. This one goes over there. So most likely this is going to join to that, but it can still join to those. This 3 either does that or that. This one always has to take this cell, because if it just takes that one, the max this can be is 4, really. Well, actually, what cell can this be if this is a cell? This can't be 9, 7, 6, 5, 4, 3, or 1. It'd have to be 2. So yeah, this one always takes that one over there. This is not an 8 anymore. It's 4 or 7. Can it be 7? That would have to do that then. Yeah, it's possible. Oh, this is a 9. This is a 7. That's a 9. This is a 7. This is a 6 now. That's a 9. This is a 1. That's a 9. This one then, oh, yeah, this goes there, so it can't go there, that'd be 3, so it has to do that. What is this cell? Cannot be 9, 8, 7, 6, 5, 4, or 2. So it has to be 1 or 3. So it's a 3, it's a 1. This has to add up to 16, which it does. This is either a loop segment, or it's 1 or 2, or it's just 2 in fact, because that one over there. This one cannot be 7, 9, so it cannot be, it has to be part of the loop. Has to do that, has to do that, has to do that now. All the way over there. This has to be a 7 now, because it's at least 5, which does that, and that. This is unshaded. This is a 7, this is a 9. This now has to do 3 over there. This has to do that. And this goes where now? Over there. So we can't return to itself, has to do that, and the loop is done. Now we just have one cell to go. Cannot be 1, 2, 3, or 5, 6, 7, 8, 9, so it has to be a 4. Oh yeah, these two as well. Oh yeah, this is a 9, that's a 6. Light finished. What else am I missing? Question mark. These are all filled in. For a trigger, exclude any digits from cells containing 2 TILL clues. 1, 1, no. 2, oh, this one, there we go. This is 13, so this has to be 3. 102 awaits. Yeah, I can see the 5-star rating. Definitely. Still flowed really well. There might have been points where I was like stuck there, but oops, still flowed really well for a 5-star puzzle. That's why they're so good. That's why I like them at least. Okay, next puzzle. Confluence 2. Dumediat's birthday edition. That's how you pronounce his name. Each row of 2x3 boxes in the grid consists of 2 sudoku boxes and 2 Philomeno boxes. Each column of 2x3 boxes consists of 3 sudoku boxes and 3 Philomeno boxes. Okay. So in every row is 2 sudoku and 2 Philomeno. Huh? How does that work? If it's 2x3. Oh, because it's 2x3, obviously. Row is 2 and column is 3. Okay. So each row is 2 sudoku, 2 Philomeno. Each column is 2 sudoku. No, 3 sudoku and 3 Philomeno. Each sudoku box contains the digits 1 through 6 once each. Among the sudoku boxes, digits cannot repeat in the grid's rows nor columns. Okay. Philomeno boxes. Divide the cells in these boxes into polyominoes so that no 2 polyominoes of the same size share an edge. Each cell in a Philomeno box contains a number equal to the size of its polyomino. Notes that Philomeno cells may contain numbers greater than 6. Also, a polyomino may cross a box boundary if both boxes are Philomeno boxes. Arrow. Numbers along an arrow sum to the number in the corresponding circle. Kropki. Numbers joined by a black dot are in a 1 to 2 ratio. Not all dots are necessarily given. Whisper. Adjacent numbers on a green line differ by 3 or more. That's right, Confluence 2. Remember how long it took us to do Confluence 1? Nah, this one's easier though, because it's only 6x6, the 2x3, which is 6x6. 6x6 Sudoku. And the rating is only 4 stars this time, instead of 5 stars. Okay, let's show what each of these rules are. First, we have 2x3 boxes in here. In the rows, there are 2 Sudokus, which I will label as blue, and 2 polyominoes. This is just an example. It's probably not going to work. In each column, there are 3 Sudokus and 3 polyomino boxes. So 2 and 2, 3 and 3. With Sudoku, let me put that right back in. With Sudoku, you have the digits 1 through 6 once each. So that's normal Sudoku rules. 1, 2, 3, 4, 5, 6 could be an example. That cannot repeat in any row, any column, or any box. So these all have to contain the numbers 1 through 6. Same for the row, same for the column. I don't really have to explain Sudoku rules. For philomeno boxes, you divide them into polyominoes so that no two polyominoes of the same size share an edge. So you can have like a 1 here, a 3 here, a 2 there. Of course, this won't work for the arrow, but that's an example. You can also have, if you have two polyomino boxes in a row, you can have something greater than 6. So you can have like a 7, 1, 2, 3, 4, 5, 6, 7 here, for example. Numbers along an arrow sums the number in the corresponding circle. And this doesn't have any weird rule about polyominoes sharing it. So it could, if this was a 4, 4 on a polyomino, that'd be at least 8. Numbers along an arrow sums the, copy. Numbers joined by a black dot are in a 1 to 2 ratio. So this could be like a 1, 2, 2, 4, 3, 6, 4, 8, and even in this puzzle you could have 5, 10 if it was a polyomino, or 6, 12, etc. And then adjacent numbers on a green line differ by 3 or more. In a Sudoku box, those are restrictive because you can either have 1, 2, 3 followed by 4, 5, 6. However, if it's in a polyomino box, it's much less restrictive, as you can have like a 12 and a 15, for example. Or even like 15 and 1, which is 14 apart. Okay, so let's get into this then. The first thing I'm thinking of is these arrows. In any Sudoku box, and even polyomino box, the least you can have on an arrow, on two orthogonally adjacent arrows, is 1, 2, which is 3. So this could be 1, 2. This could be 1, 2, making 6 already. And this could be like 1, 1, making 2, 6, 8. So this is at least an 8, which means this one has to be a polyomino box, a philomeno box. This one, though, could be 1, 1, 3, 3, 4, 5. Could be a 5. If this was a Sudoku box, it'd be 1, 2, 1, 2, which is a 6. Though. How about this one? If this were a Sudoku box, this would definitely be polyomino, because one of these is a 6, adding up to at least 1, which is at least a 7. If this were a polyomino box, well, could this ever be a Sudoku box? Only if this were a polyomino box. Then you could have like, I don't think that's what we're thinking about, actually. If this were Sudoku, no. This one has to be polyomino, because this is equal to these two, which cannot repeat. Digits cannot repeat in a Sudoku box. This is polyomino, and these are all the same number, which is at least 3. So this is 3x. This one definitely can't go there. Also cannot go there, because this one cannot be a 0. And it couldn't go there because x is not 2 times or 2 divided by x. Or x is not x times 2, it's also not x divided by 2. So it cannot come to there. If this was Sudoku, the least this could be is 6, 9, 10. Ah, yes, this is if this is polyomino, even if this is polyomino, the absolute least this could be is what I showed before. No, not what I showed before, but I can show it now. 1, 2, 1, 2, 1, 1, 3, 6, 7, 8. So, and if this were 8s, then how is it going to get out of the box? Because it has to. There's only 6 cells in this box. It cannot pass any of these lines over here. Otherwise, every single other line would on this arrow would have to be equal to 0, which is not possible in Sudoku or Philomeno puzzles, or at least this normal 6x6 Sudoku. You could if it was, if the digits were from 0 to 6, but then again, there'd be too many zeros that you have to put in there. So it has to get out through this over here. It can take these 3 cells, but it has to take at least 5 more, which means this one is polyomino. And these are both Sudoku. This is at least a 3. This is at least a 3, whether it's polyomino or Sudoku. Because polyomino is, and Sudoku is the least you can have here is 1, 2. 3 and 3 makes this a 6. This is 5 or 6. In fact, this 6 goes up here somewhere. It can't go in this line because this can't be more than 6, so this has to be 6. This is 1, 5, 2, 4, and this is a 3. This is a 4, 5. Because we have a 1, 2 pair over here. What's the most this can be? I think it has to be part of this. Because suppose this one this did not take that. Then you'd have 1, 2, 3, 4, 5, 6, 7, 8. At least this. But it could, again, it could do that though. However, whether it does this, or it goes into this box and takes one of these cells, that means that this cell is at least an 8. So this over here has to be at least a 9. And where does that go? It cannot go into any of these arrow cells over here. Otherwise these would be 0. And it can only fit 6 cells in this box. So that can't go into there. And if it went like this, if it didn't take that, then what is that cell? It can't go over here, so it has to be a 1. How are these going to add up to 1? It's impossible. You can't have 0, 1 here. So yeah, these have to be the same number. And because they can't go over here into these things or into those things, they are at most a 9. This is 8 or 9. Which means that this is a polyomino box. A philomeno box. If this was Sudoku, then that would be 6. This would be at most 3, this would be at most 1. 3 plus 1 plus 6 is 10. So this is polyomino. If this were 9, it would do this. This can still be an 8. We have like 1, 2, 2, 1, 1, 2. Wait, can this be an 8? Yeah, if this were an 8, then this would be 1, 2. 1, 2, 1, 1. No, it cannot be. Wait a minute, wait a minute, wait a minute. Yeah, it can. Like that. It can still be an 8 like this. This is an 8. Yes, oh my gosh. Ugh. This is all polyomino. The least these can be is 1, 2, 1, 2, and 1, 2. 3, 6, 9. So this has to be 9. Which means that's a 9. Which means all of that is a 9. Because this is 1 and 2, this one has to be 1, this one has to be the 2. Same for this. That's done. This 2 could go there or there. If this were a Sudoku box, how is that possible? 3, 6, 4, 5, 1, 2, 6. Yeah, that's how. This is 1, 5, 2, 4, 3, 3. Boom, boom, boom. If this 2 went here, that would be a 7. I haven't seen any problems with that so far. Do 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 do. Da 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 do. Ba da ba boo doo ba boo doo ba boo. If this is Sudoku, this is at least a 7, making this at least a 10. 7 plus 3 is 10. This would have to be polyomino. The least this is a 6. Because that's at least 1, 2, that's at least 1, 2. This is equal to these 3 cells. Can this really be a Sudoku box? The only way this could be Sudoku is if this is polyomino, because this equals at least that. And this would have to be 1, 2, 1, 3, 4, because this would have to be 4. It couldn't be 5 or 6. That'd be 6. Yeah, that breaks. Okay, so if this is Sudoku, and this is polyomino, this has to be 1, 2, making this a 1, 2, making that a 6. Now this one has to add to 1, 2, plus 1 is 4. What is this then? It can't be a 2. Also can't be 3 or 5. So yeah, this one's definitely polyomino. Because this is at least a 6, has to escape because it can't take those. So either goes there, there, or there to escape that box. It definitely can't only take that box, because that would make it at least a 10. You have 1, 2, 3, 4, 5, 6, 7, 8. Could take those. So I have to take at least that one or that one as well. This is 3, 4, 5. Definitely a 3 in there. dog, shut up. Why you gotta be so annoying? If this is only a 6, this is a 1, 2. Those two have to be the 1. Oh, that breaks. Okay. Yeah. This one can't be a 6. Because if it were a 6, you'd have to have 1, 2 there and a 1, 2 there. And either you have 2 1s here, and then that's a 2 you can't escape. Or you have 2 1s here, and that 2 touches another 2 phenomena of size 2, which is impossible. Upsy-daisy. So this is at least a 7 now. One of these definitely is a 2. So either that 2 goes there, or that 2 goes there. That's with at least a 3. 5 plus 3 is 8, so this is at least an 8 now. This has to at least add up to 5. So this is at least a 6. 6 or x. Does not go there. I also very much doubt it goes there, but it's a possibility. We can't go here. I also can't take any of these cells, because this is equal to those 3 cells, and none of them can be 0. So we can't go onto one of them. Which means it has to go at least down 1. So that's a polyomino cage. Yeah, polyomino cage. Or box, I guess you can call it. Oh wait, this is only the case if that's a polyomino box. This could be a Sudoku box. In which case this would be 3, 4. Which is more than 5. Yeah. So this still works. The logic behind this still works. Let's go down. One of these at least is a Sudoku box. Can they both be Sudoku boxes? This couldn't be 1, 2, staring at that one. It also couldn't be a 3, because then both of those would be 6s. So these would have to be high, 5, 6. Making those 1, 2, 3. So those ones would have to be 1, 2. And I see no problem with that. Actually, no, they could be 3 because of that. It's being polynomial. Can this be polyomino? Those would both be Sudokus. Yeah, this is what I was just doing. It'd have to be 5, 6 with 1, 2, 3. That one would have to be the 3. Making that a 6. That a 5. That a 1, 2. That a 1, 2 as well. Ah, yes. There we go. Okay, so if this were polyomino, both of these would have to be Sudoku. This could not be low. And on German whisper lines, when I say low and high, I mean that because they have to differ by at least 3, if you had a 1, the next thing on the line would have to be at least a 4. Could be 5 or 6. If it was a 6, the next thing on the line would have to be at least a 3. At most a 3. Could be 1 or 2 as well. I was going to keep on doing this. 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, low and high. Just like on a regular German whisper line. This one could not be low. It cannot be 1, 2, 3. Because there's already 1, 2 here, so this would have to be a 3 somewhere. And what can 3 see? 3 sees 6s. It can only be, the only thing 3 apart from 3 is 6 in 1 to 6 Sudoku. So all of these would have to be 6, and there's way too many 6s looking at each other. Up there, down there, side to side. That's impossible. This one has to be high. It has to be 4, 5, and 6. It cannot be a 4, because then both of them would have to be 1 looking at each other. And yet again, yeah, that's impossible in a Sudoku. So they both have to be 5 and 6. These then have to be 1, 2, and 3. So one of these is 3. One of those is a 3. Well, not necessarily. One of those is a 3. So we're looking at that one. It cannot be that one. Otherwise, both those would be a 6. That would be a 6. No. I think I did something wrong. No, okay, I see where I made the mistake now. This one still can be the case, because you have 3 there, 6 there, 5 there, 1, 2 there, and this is not looking at Sudoku box over here. So that's fine. Never mind, this is possible. Boom, boom, boom. Where does this go? 1, 2, 3, 4, 5, 6 it could be. You can go there. Okay, so. Ah, these both. Yeah. These both are polyomino boxes. This one has to be Sudoku boxes. Which means if this was Sudoku, this one is at least a 7. This is at least a 1. 7 plus 1 is at least an 8. This is at least an 8 now. But where can it get its cells? Sorry. No, this is still, yeah, never mind. 1, 2, 3, 4, 5, 6, 7. Could get an 8 there. Because this is Sudoku, this you play Omino. However, what I'm showing here is that if this is Sudoku, that is polyomino. Because this is at least an 8. It can take 6 in here, it can take 1 in here, it has to take 1 more. But it could be this one. It could be that one. That makes sense too. In fact, if this went here, this could even go there. So that'd be 16. Actually, what's the highest this can be? It can't take any of these cells. It can't go below. It can't go below this line of the grid. It cannot go to that side of the grid because there can only be 2 in each row. So it couldn't possibly travel 3 across. Definitely greater than 1, 2. So what's the highest it can be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The most it can be is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. And it couldn't be any higher than that if you take this one over here. Because this is at most an 8 over here. So this is at most 13. Wait. That means this can still do this. Because this would be 12. This would be 6, 6. That'd be 12. Yeah, it's possible. Wait a minute. No, it's not. It's not possible. This one cannot go there. If it did, this is at max 12. Because it can only take 13 cells over here. This is at min 6. So, talk, please shut up. If this goes here, this is 12. It can't take any of those. And it can only take these cells over here. It can't take just these, so it has to take that one as well. And then it's boxed in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It couldn't take those. It had have to take that one. Right. It couldn't take those because then what is this? 1 makes at least 2. This has to escape somehow. It's not possible. Also, this isn't even possible for a different reason. If this took those ones over here, which it has to 1, 2, 3, 4, 5, 1, 2, 3, 9, 10, 11, 12. Wait. Yeah, it can't take that one because that would be 0. This is 11. It would have to take one more over here. This one, these both have to be Sudoku. I just couldn't get out. So that one has to go down there because that one has to be taken. And then that's forced. And then, what's that? This one has to be a 1. That's a 12. This has to be 11 in a Sudoku box, which is impossible. So yeah, that's all to prove that this one can't go there. That cannot be a 12. Ah, dog needs to shut up. So, can this be Sudoku now? Yes. If it is, that would be at least an 8. 6, 7, 8. But it couldn't be an 8. It couldn't just do that, because that would have to be more than 1. It would have to go over here somewhere. Otherwise, this is the 1, and then this one goes over here somewhere. So if that's Sudoku, this is polyomino. And then this is Sudoku. If this is polyomino, then these are both Sudoku. So this one is always Sudoku. That's what I'm trying to say here. We can also ask if this is Sudoku, what happens? No, sorry. If this is polyomino, what happens? These are both Sudoku. If that's polyomino. And then this is at least 7, that's at least one more, which is 8. The least this can be is 3, 4, 1, making this an 8, which is the least it can be to fit in here, but then this is broken. So yeah, this one is a Sudoku box. If this is Sudoku, where does this go? Have to go over here. These would all be Sudoku. This would 1, 2, 3, 4, 5, 6, 7, 8 could even be could be the case. No, it couldn't be that because that would be 1, that'd be 7. And 7 is not a Sudoku digit. Sudoku box. This one couldn't even go there. These would be Sudoku. This is at least a 10. Is that possible? If this is Sudoku, this is at least a 10. These are both Sudoku. But then where does it get its 10 digits from? It can't go in here, because that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It couldn't take all of those cells, because that would be 1, that would be a 9. 9 is not a Sudoku digits. It couldn't do that for similar reasons, because then this is at least a 2, we can't get out anywhere. So it has to take all of those, and it has to take 2 more of those. Which has to be this one, and that one. But then what's this? It can't go past that black dot. It also can't go past there in general because it's a Sudoku box now. And it has to be at least 4. That's impossible. This is not Sudoku. This is a polyomino box, making that a Sudoku box. This now is at most an 8. So this is 6, 7, or 8. This is 1, 2, or 3. These now cannot be 1, 2, 3 from what I showed before. This is 5 and 6. These are 1, 2, and 3. Has to be a 3 on one of these. It has to be this one. That's a 6. That's a 5. This is 1, 2 pair. That's a 1, 2. This is not a 5. This one is a 6. This is 3 or 12. This is 3 and 4. This is 1 or 2. This is 4 and 5. This is at least a 6. This is 6, 7, or 8. These are both Sudoku boxes now, making this a 3, 6, 4, 5 pair. This is a 1, 2, making this a 6. Whether it be Sudoku or otherwise. In fact, does this have to be Playomino? 1, 2, 3, 4, 5, 6, 7, 8. No, it does not have to be. This one can still fit like that. Ah, but no, it cannot. Because if this did that, an 8 like that, then this one has to be either half it or 2 times it. It cannot be 16, it cannot be 4, which is impossible, so it's impossible. This one has to be polyomino, making all of these Sudoku and all of these Sudoku. These all of these are Sudoku and all of these are Sudoku, so all of these are polyomino. And we have distinction between the polyomino and Sudoku boxes. What a very symmetrical grid. Not really. Not symmetrical, but it has one here and all of these here. This 2 goes here. This is no longer a 3, 3. It is 1, 5, or 2, 4. This is 2, 3, 2, 4, 2, 5. If this were a 6, it would join to that 6. If this were a 7, it would join to that 7. If it were an 8, it would join to that 8. Because this has to take at least 4 of these cells. And this has to take at least 5 of these cells. So they have to overlap somehow, which means they are the same. Yep, all Sudoku squares and all the polyomino squares as well. This one can't be a 5. This is 1, 2, or 4. It definitely has a 2 in it. This one is not a 4. This is not a 1. There's a 4, 5 over here somewhere, so this is a 3, 6. Oh my god, does this dog ever shut up? This is 1, 2, and 4, because in a Sudoku box, these digits always are either 1, 2, 4 or 3, 6. With a 2 in it or a 3, 6. And it cannot be 3, 6. So this one's a 5 now. This is not a 2, this is not a 4. This is a 4 over here, so this is a 5, this is a 1, this is a 2, this is a 4. These are not 5, these are not 1. These contain a 3 and a 6. These are not 5, so these are not 4. This is a 2, this is a 1. This is a 4. This is a 1, 3, 6 pair. It's not a 6. Ah, this one now has to be a 10. Where's 10 go? It leads to there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. At least. This is 3, 4, 5. This can still be a 3. Impressively. Get it done, get it done, odore. If this is an 8, this has to be a 4. So we already have 8 cells taken up here, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is at most a 5. We also know that this does not go there. So if this is an 8, that's a 4. 7 does not work, cannot be 14. 6 could be a 3. That 3 or 4 goes there. If that goes there, then this cannot fit. Also, this is a 10, isn't it? 5 plus 2, that's at least an 8. So if that goes there, 1, 2, 3, 4, 5, 6, 7, 8 is possible actually. But this one always has to go here. So we're learning. Does not go there. If that is an 8, that's to be as a 5. Set most 10. This is 6 or 8 or 2. 6, 8 or 2. Although if this were 2, then 1, 2, 3, 4, 5 is not possible. That's 6 or 8. But notice it is possible. No, it's not. If this were an 8, and that were a 4, and that were a 2, that'd be 2, and this has to be take 8, it's not possible. Yeah, okay. This one's 1, 6, or 8. This one's either 6, 3 in this order, or 1, 2, 4 with the 2 is somewhere on there. This has to take this cell. 1, 2, 3, 4, 5, 6, 7. Yeah. Has to take that cell. This is 8 or X. Or is 8 or more, I mean. This definitely can't be a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would make that a 5. But there's already 5 there. So this is an 8 or a 9. So this can't be a 7. Otherwise those would both be 1. So it's either 2, 3, or 2, 4. If it's 2, 4, that would have to be a 2. That'd be a 1. Oh, that's broken though. Yeah. If this were a 2, 4, I mean, add up to 6, we have to add up to 8 over here. So that's a 2. But then what happens? This 2 cannot go there, otherwise there's 3 of them. And if that 2 goes there, then how does the 4 get out? It can't. So this isn't 2, 4, this is 2, 3, definitely. This is not a 2. In fact, we know that because of 5 plus 1 or 5 plus 3. This, to add up to that, is either 2, 3, or 1. 1, 2, or 3. And it could go there or there. If this were a 3, making that a 6, the 3 would go down there. And that 6 would finish like that. That would be a 3. Actually, hold on a minute. Also, I don't think I can go there. You could just do that. 3. But anyway, if this is an 8, 1, 2, 3, 4, 5, 6, 7, 8, right? That's the max you can do. 8 there. Making that 9. There's just not enough space. That's an 8. That's a 9. The 9 can take those cells. And then, because that's an 8, this has to be a 4, but where can it get its 4th cell? It cannot. So this one is a 6. Making this a 3. Making this a 2 or a 3. Making that a 1. 5 plus 1 is 6. This is a 2 or 3. If this were a 2, that'd be 1, that'd be 3. Where can 3 get out? It cannot escape. So this is a 2. This is the 1. This is the 3. 3 has to go to at least there. This one has to be at least a 3. It has to get out, so it has to join the 3. That's 1 or 6. This is 1, 2, 3, or 6. What is this? 1, 2, 3, 4, 5, 6, 7, 8. Has to do that. This is an 8. This is a 3, that's a 5. This is a 2, that's a 2. This is 1 or 6. 1, 2, 3, 4, 5, 6. Has to be those two. All of those are done. That top area is done. This is not a 5 anymore. These are at most 3. This is not a 5, so this is a 5. These are 1, 2, and 3. This is a 4 now, so that's 3, that's a 4. Will that dog please shut up? This is a 3, that's a 4, that's a 3. That's a 4, that's a 5, that's a 3. That's a 5, that's a 2, that's a 4, that's a 1. That's a 1, that's a 2. 1, 2, 1, 2, 4, 5. That's not a 4 anymore, that's not a 1 or 2. This is not a 1. This is 3 or 4, 2. This is 1, 2, and 3. That's not a 3. This is 4, 5, and 6. It's not a 5. So this is a 5. This is 4, 5, 6. This is 1, 2, 3. This is not a 5. That's not a 5. So that is a 5. These two are 4 and 6 because of this pair in the column. This is the 1, 2, and 3. Seriously. How can it bark for so long? This could be a 1 or 2, or it could be an 8 or higher. This is not a 4, 5 pair. It's a 3, 6 pair. That's not a 3, that's not a 1. This is a 4, 5 pair. This is a 3 now, that's a 6, that's a 1. 3 and 6, 6 and 3. That's a 6, this is a 1, 2 pair, this is a 3. This is not a 3 anymore, so that is a 3. That's a 2, that's a 4, that's a 6. 6, 4. 6, 4. 2, 1, 3. 2, 1, 1. 1, 2. 2, 1, 5. All the sudokus done. Now it's just time for the polyominoes. This is the 1, that's a 2. 2 can't go there because that's not 5, that's not 3 away. That's a 2. That's a 1, done. These add up to 10. Could be a 1, 9. Cannot be the other way because it can only fit 2 over here. Could be a 2, 8. Cannot be 3, 7. Cannot be 4, 6. Could be 5, 5. Is she finally done barking? Oh, peace. Bless. This is at least a 5. Cannot go there. Has to go there now. It could go there, but then it couldn't escape over here, so it'd have to go here now. Oh, she's back up. It can only take one of these, because they both see each other. And 5 is not 3 away from 5. Let's take one more over here, 5x. And that one can go over here. This can be a 1, 2, or an 8 and higher, but it cannot be 8 and higher. Because if it was 8 and higher, it'd have to escape through here, but then it touches this. Not allowed. Too naughty for words. This is 1 or 2. Cannot be a 2, because then it would have to go here, and that 2 is not 3 away from 1. It's 1 away from 1, so that's a 1. This now has to be at least 3 away from that, so it's at least a 4, so it has to turn into this one. It's 5x. 5 or higher. We can draw these as well. Okay. This one cannot be 1, has to be higher, so it has to join to that thing. So this thing cannot go there. 1, 2, 3, 4, 5, 6. This is going to be a 7, because this is going to be a 1. So this one has to be join that one. So this is a 7 over here. This has to be 3 away from that, which could be a 10 still. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. Still possible. How many things are there here? 6, 12, 18. Yeah, there are 18 cells in here. Because it's 6 times 3. There are already 10, so there's only 8 left over. Which means these cannot add up to 10. They cannot be 2 separate things that add up to 10. Otherwise there'd be 20 cells over here. It's impossible. So they have to be the same cell, they have to be 5 and 5. This can only take one of these two. And it cannot go there, because that is 2 away from 7. So it has to go there now. This one has to go here now. 1, 2, 3, 4, 5, 6, 7. This one cannot go here, because then this would have to be a 10. But it cannot join to that one, that's too many cells. And in fact, if you have to do that, that's way too many cells. And it couldn't be a separate 10, because that'd be at least 20 and 18 cells. This is either 1 or 10. This is either 2 or 5. This 5 has to go to at least here. Cannot go there again. Could go there though. One, 2, 3, 4, 5, 6, 7, 8, 9, 10 has to do at least that. It could go there still, if that were 1 and that were 2. In fact, that's what's going to have to be. The reason why is because what is this cell? It cannot be 3 more than 7, because that's 10 or more, which is not possible from there. So it has to be 3 or less than 7, which means this is 1, 2, 3, or 4. It can't be 4, because 4 is not going to fit in here. It can't be 3, because 3 is also not going to fit in there. That's 2 or 5. So it has to be 2 or 1. If it were a 1, this one can't be a 2, it has to be a 5. But then what's this cell? It would have to be 1. In fact, 1, 2, 3, 4, 5, 6, 7. There are 7 cells in here. This has to be a 5 and 2. So this one is a 2. Where does this 2 go? It can't go here, because 2 is 1 away from 1. It has to go up there. This has to be 1 now. This has to be the 5. And that one has to be the 10. There we go. 6604. Good 4-star puzzle. Nice. Significantly easier than the last confluence puzzle. Thank you. Okay. Next one then. Synthwave. Normal Sudoku rules apply. Every line is both a red band and a region sum line. Digits on a line form a set of non-repeating consecutive digits, and digits on a line have the same sum in each box the line is set in. Okay. This one's going to be pretty easy, probably. Because region sum lines and uh, Renban lines, when they're put together, are pretty easy to do. And I'll show you why. So, first of all, let's give the definition for each of these. Renban line is a set of consecutive digits in any order. So this could be 2, 3, 4, 5, 6, 7 would be a valid consecutive digits line, or Renban line. And a region sum line would mean that you could have like 2, 7, 3, 6, 4, 5, all the way up to 9. Okay? And these are both Renban and region sum. So let's get into it. One thing we know about region sum lines is that the shit, what the fuck is it called? The combination of Ramban and region sum lines is that they're always going to add up to an even digits because they're in two boxes, they're region sums. And because of that, if it is odd number of cells, it is going to have more even digits than odd digits. Because if it was an odd number of odd digits, that'd add up to an odd number. Odd, even, odd is going to equal odd number. But anyway, let's not get into that. Let's actually just get into this. What can this be? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 cells long. Which means that this cell over here has to be the 9. And these are all going to add up to 9. 1, 8, 2, 7, 3, 6, and 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. This is an 8 cell divided into 3 boxes. Which means that also I forgot you can also have odd totals. But anyway, either it's going to be divisible by 3. So either you have 1 through 8s, 1 through 8s, which is going to equal 36, or you're going to have to get 2 through 9, which is going to equal 44. Which of these two is divisible by 3? Is 1 through 8s, adding up to 36. And it would divide each box into 12, because 3 into 36 is 12. 44 is not divisible by 3. These two add up to 8, which is not a number divisible by 3. So this has to be 1 through 8s. 1's on one of those, 2's on one of those. This is either 9, 3, 8, 4, or 7, 5. Okay. But we do know that this is 1 through 8, so I'm just going to do 1 8. She was tired for a second. 1, 2, 3, 4, 5, 6, 7. Because these go into 2 boxes, it has to be divisible by 2. And 1, 2, 3, 4, 5, 6, 7. If it's either 1 through 7, 2 through 8, or 3 through 9. 1 through 7 is going to equal to 28. 2 through 8 is going to equal to minus 10 is 35. And 3 through 9 is going to equal 42. Yeah, so it's not 2 through 8. It's either 1 through 7 or 3 through 9. And this line is either going to add up to 14 or 21. It's not very constrained. How about this one? This is 7 divided by 3 this time, though. And again, we have 1 through 7, 2 through 8, 3 through 9, which is 28, 35, and 42. 28 is not divisible by 3, that adds up to 10. 35 is not divisible by 3, that adds up to 8, so it has to be 3 through 9. And it's going to equal 12. 3 into 42 is 12. Yeah. No. 3 into 4 is 1. 12. 3 into 12 is 4. This would be 14, wouldn't it? How's that possible? Oh, yeah. No, this is possible. Because this is 9, 5, or 8, 6. I thought these were 2, sorry. So this is either 9, 5 or 8, 6. It can't be 9, 5 though, because this is 1, 2, 3, 4, 5. This contains it. Because this is a 5-cell random band. Hello. It goes well. I'm on. Going backwards from the last page, I'm on the third page. Thanks for stopping by. But because this is a 5-cell random band, it has to contain a 5 on it. Because if you don't have a 5 on it, then how are you going to get 5 consecutive digits? So you'd have 1, 2, 3, 4, can't go to a 5. 9, 8, 7, 6, can't go to a 5, it doesn't have a 5 on it. And those are only 4 each. So 5 has to bridge them, which means there has to be a 5 here, so this cannot be 9, 5. This has to be 6, 8. The 9 then has to join with the 1, 3, or 9. No, this one has to be 9, 5 over here. And the rest of these are 7, 4, and 3. I add to 14. The last two cells over here have to be 1 and 2. They see the rest of these over here. This is 6 or 8. It's the cell over here. And now this is either 1, 2, 3, 4, 5, or 2, 3, 4, 5, 6. It cannot be 1, 2, 3, 4, 5. Because if it was 1, 2, 3, 4, 5, this would add up to 15. But then what's 15 divided by 2? 7.5. And there's no 0.5s in Sudoku. So this is 2, 3, 4, 5, 6. Adding up to 20, 10. So this is 4, 6, and this is 2, 3, 5. This is a 6, this is an 8, this is an 8 now as well. Again, I'm really sorry for the dog in the backgrounds. Let me actually be right back so I can see what's wrong with her. Maybe she needs to go outside. Okay, I have returned. Got one of my nephews to walk the dog. Okay, let's continue. This is 4, 7, and 9, so this is a 7, this is a 4 and 9. This one doesn't necessarily have to have an 8 on it. Could be 1 through 7. It is 1 through 7 or 3s and 9s, though. And up to either 14 or 21. These three cells are 1, 3, and 5. So this is either an 8, a 6, or a 4. It cannot be 6 or 4, so it has to be 8 with the 1 here. This is roping now. 1, 3, or 5 goes over here. This is 2, 7, and 8s. This is 2 and 7. This is 4, 6, and 9. One, 2, 3, 4, 5, 6. 6 divided by 3 could be 1 through 6, which is 21. Cannot be 2 through 7, because that would be 27. Yeah. Yeah, 2 through 7 is 27, which is not divisible by 3. 3 through 8 would be, 45 minus 12 is 33, which is possible. And it cannot be 4 through 9. Hello, Izmuk. Who's Demasi? I know that they were in chat, but who are they? It's either 7 or 11 on this over here. 7, 4, 3, 8, 5, 6 would be the thing over here. That's not possible. Oh, hey, Skojo. Oh my gosh, I have Skojo on my stream. Nice. For anyone not in the know, which is probably Charles, Skojo is a pretty famous setter. I've done a bunch of his puzzles, they're pretty good. Let's see. Yeah, so this one cannot be 3 through 8s, adding up to 33. Because if it were, then this would have to be 7, 4. This would have to be 3, 8s, and this would have to be 5, 6. And then we have 3 and 5 looking at this cell over here, which breaks it. So this has to be 1 through 6, adding up to 7 each. 1, 6, 2, 5, and 3, 4. This one has to be 3 or 5. Adding up to 4 or 2 to get 7. This one can be 1, 6, or 2, 5. This one can be 1, 6, or 3, 4. I wouldn't say Skojo is famous. Okay. I mean, I guess it really depends on how you define famous, but in terms of Sudoku, he's pretty famous. Well, it's okay to be wrong here and there. 8 goes there in that box. 7 goes in one of those. 8 goes in one of those. Which means it has to go over here in that box. What, you're telling me that you haven't done the rat face puzzles? Fistmafel definitely is the most famous. He also gets he he also always gets what's it called? A special thumbnail every time he does one. Hello, Worm. Welcome to the stream. I mean, I've done your puzzles. Though I would not say that you're as famous as Gojo. Sorry. These are not the 8. 8 is only one of those. This adding up to 36 divided by 3 is 12. So either is 8 here with a 4, or 8 here with a 1-3 pair. Yeah, I have. I also thought you weren't you in one of the recent CTC videos? But besides that, I've done a couple of puzzles that you've done for packs. I forgot which pack it was though. 8-1-3 or 8-4 over here. 8 could still go over here on this one. If it did, then this would be 3 through 9. What day on the list annoys you? Also, I mean, let me check now which puzzle I've done for you. I'm going to go to my puzzles that I've solved. Actually, let me just go here. LMG or LMD. No. What's your do you have a LMD page? The bookworm. Ah. Well, if I have, I've definitely never put on LMD. Maybe I'm thinking of someone else, or I'm thinking of a puzzle name. Octoquadri. These look familiar, though. I've definitely been to these. Because they're purple. Yeah, I've done these ones before, I just haven't put them in here. And this is the pack that I remember doing, the Octoquadri pack. As you can tell from all of these, they've been opened before. Yeah, those are the ones I remember. One is definitely not on this one over here. Because if it was, then either, then 8 couldn't go there, because this has to add up to 14. 12, I mean. And, well, one just can't go here in general, because it has to add up to 12, obviously. Oh, hey, pianist. So many people showing up. Thanks everyone for coming. This is not an 8 because then it would go over here and there'd be two 8s on this band line. 8 is definitely one of these now. You should go to it. You should sign yourself up for an LMG account because then you could play a bunch of sudokus there and you can keep track of them. After I do this one, I'll show you how many puzzles I've solved on there. What is it? This is 9. Where does 9 go in this column? We know that actually we could just have 9 goes here in this box, so it has to go over here in this box. 4 is one of those. We have 1, 6, 2, 5, 3, 4. 1, 6 definitely here. And then either 3, 5 or 2, 4. Sorry, either 3, 4 or 2, 5. Which means this is 2 or 4 over here. Well, thanks for stopping by. I'm glad to have it, everyone. Well, I'm new to streaming Sudoku on Twitch. I'm not new to streaming, but new to streaming Sudoku. But I've been everywhere solving. Let's see. What's this in this puzzle? If this were an 8-4, then what would the 1 be with to add up 11 more? It couldn't be 8-3, it couldn't be 7-4, it'd have to be 5-6. It would be 1-5-6, 8-4, 1-5-6. And then the other would be 2-3-7. Otherwise, we have 8-1-3 over here. Then 2 has to add up 10 more, which would be 2-4-6 and then 7-5. Both seem to work. It's either 8-4 or 7-5. These definitely have 5 and 7 on it, though. So if this is 5-7, then 5 and 7 have to go over here. And this either adds up to 14 or 21. If you're 14, it would have to have a 2 over here. For 21, it would have to have a 6. No, a 9. Hmm. If this is 8-1-3, what am I missing here? What is this 7? I checked out the spotlight, and that's a lot of puzzles. Hmm. What do I do next? How does this work out next? What am I missing? What is this? 2, 7, 3, 6, or 4, 5? This can't be 4, 5. Otherwise, this is 5. It's broken. So either this is 2, 7, or 3, 6. So there is a 2, 3 pair over here in this box. If this is 4, 5, then we have 4, 5 over here. There we go. This one cannot be a 4, 5. This one has to be a 4, 5. Because if this were a 4, 5, then both of these, since this is a 7-cell round band, has to have 4 and 5, 4, 5, and 6 on it, and 3 and 7. But if this were a 4, 5, then this would break this one, which has to be either 8, 4 or 7, 5. So that means that this one is a 4, 5. This is 2, 3, 6, 7. 2, 7, or 3, 6. I mean, this one cannot be a 1, therefore. 1, 8, 3, 7, 4, 5. Yeah, because if it were, then it would have to add up. It'd have to have 2 more adding up to 11, which is either 8, 3, 7, 4, or 5, 6, which all options are taken away by these cells. So that's not a 1. The 1 is over here. Which can either be 8, 3, 7, 4, or 5, 6. All those seem to work so far. Nah, super spicy wings is barely a challenge. Depends on the spice. My highest spice is, what was it? Reaper plus Ghost. I forgot the exact name of it, but they combined Reaper and Ghost. It's pretty hot. If one of these is an 8, that makes that an 8, which means this has to be 1 through 7. This is 1, 3. So this has to be 1 and 3 over here. 1, 3 makes that a 2, 7. So 1, 3, 2, and 7 are all over here. 1, 2, 3, 7 is 13. There we go, it's broken. Okay, this one cannot be an 8. The reason why is because if one of these is an 8, then where does 8 go in this box? It has to go over here. We know that this has to equal 12 because it is 1 through 8. And that's 36 divided by 3 is 12. So this would have to be 8, 1, 3. That makes this have to be 2, 7. And now this one cannot have an 8 on it, so it has to be 1 through 7. But we have 1, 2, 3, and 7 over here already. So the 1, 2, 3, and 7 have to go on this side, and that equals 13. However, 1 through 7 is 28, and 28 divided by 2 is 14. So that cannot be the case. 13 is not equal to 14. Therefore, those are not the 8. The 8 is over here, with the 4 over here. Which means this one has to be, cannot be 1, 3, 8, cannot be 1, 7, 4, it has to be 1, 5, 6. Also, this can be 3, 6, or 4, 5. It can't be 3, 6 anymore. This is 2, 7. This has to be 2, 3, 7. I add to 12 again, so that makes this a 6, that makes that a 3. This is no longer 3, 4, it has to be 2, 5, this is 1, 6. This is 3, 4. Oops. This is a 4, that's a 3. 2, 7, where is it in this column? Can't be there, can't be there, has to be, the 2 has to be here. Where is 7 in this column? Can't be there, can't be there, has to be one of these two, can't be that one. How incredibly brave of you. That's a 5, that's a 4, this is not a 4 anymore. 7 has to go here. In fact, this is a 3, this is a 4. This has to be 2, 5, 9. This is a 2. This is 1, 6, 7. 4 has to go over here. Where does 8 go in here? Has to go there. This is 3 to 9 now, and this has to equal 21. Yes, because 3 to 9 is 42. 42 divided by 2 is 21. 8 then needs 21 is 13 more. So this is 4, 9. And this is 3, 5, 6, and 7. This is 1, 2, and 9. This is the 1 in this row. That's not a 1. Only with milk on standby. This is a 5, that's a 3. This is a 5 now. That's not a 3 anymore. It's not a 3. 3 goes here, so that's not a 3. This is a 3. This is a 2, 7 pairs, so that's not 7 anymore. This is a 7. That's a 7. That's a 2. That's a 2. That's a 7. That's not a 2. These are not 4s, so that's a 4. We have 1, 6, and 9 to go in this box. That's not a 1. That's not a 1. This is not a 6. This is a 1, 9 pair. This is not a 2. This is a 9, because 2, 5 is looking at it. This is a 2. This is a 5. This is not a 9 anymore. This is a 1, 9 pair. That's a 2. That's a 2. That's a 7. These are no longer 7. That's a 7. This is a 6. That's a 1. That's a 9, 9, 5, 1, 9, 6, 1, 6, 9. Oh, okay. I placed the wrong digit in there. Oopsie daisy. That's not a 1, because this is 1, 5, 6. This is a 3. Oops. That makes this a 3. That makes that a 3 out of 5. That's not a 5 anymore. That's not a 3. It's a 2, 7 pairs. That makes that a 6. This is a 3. This is a 4. That's not a 2 anymore. So that's a 2. That's a 7. That's a 7. It's a 6. It's a 1. And then 2 goes up here. 5 goes here. That's a 9. This is a 6. That's a 1. This is a 1. That's a 1 now, which makes that a 1. That a 5. That a 9. 2, 5. That's a 1. It's a 3 and a 5. That's a 5 and a 6. This one's an 8 now. That's an 8. That's a 7. 1. 4 and 9 to place in here. This is a 4 and a 6. 3 and a 5. We should be close to finishing now. 6 and 9 to go in here. That's a 6. It's a 9. 9, 2, 2, 7, 2, 7, 5, 7, 9, and 4. Nice. It's a little puzzle. Thank you, thank you. But yeah, I knew it was going to be fairly easy, and by fairly easy, I mean like a 3-star. because of these lines. These lines are always really fun to deal with. But yeah, if we go to my LNG page, I was going to show you how many puzzles I've completed. Pretty sure it's less than 1,000, so don't expect anything too great. Oh, it is 1,000. 1,810. So almost 2,000 actually. Yeah, it could be more. Which sorry, I'm doing this quest. No, I'm kidding. Uh, Surprisingly, I have almost as little 1 stars as I do 5 stars. 27 of these, which is just these means that the rating hasn't been set yet. Which usually happens if you have less than 12 solves on it, I think. I forgot the exact number. Uh, I've been watching CTC for what is it? Since basically since COVID. A little bit after that though, because it was the one that they always say is the most famous one that got them popular is the one that I started, and it was like 5 weeks after that one came out because I kept on seeing it in my recommended. I never clicked on it, and then one day I did click on it, and then I got hooked. And then after that, I got introduced into the various Sudoku worlds, and it's just been so fun after that. Less than 10 ratings, and it often takes more than that amount of solves to get rated. Gotcha. Cool. And as you can see, I've published nothing because I am not a setter. But anyway, on to the next one. 10 types of lines. Normal Sudoku rules apply. Digits in a circle appear at least once each in the four surrounding cells, from left to right, top to bottom. The following lines have the following properties. So digits in a circle just means a quad rule. Not a setter yet. Maybe one day. Maybe one day. I just don't have the skills for it yet. Whisper, green. Adjacent digits differ by 5 or more. Thermo, gray. Digits increase from the bulb to the ends. Renband, purple. The line contains a set of consecutive digits, not necessarily in order. Between lines, gray. Digits on the line are between the values in the circled ends. Region sum, blue. Digits on the line have the same sum in each box the line is in. 10 line, gray. The line consists of one or more contiguous groups of cells, each of which sums to 10. Groups cannot overlap. Nabner, gold. No two digits may be consecutive. Parity, red. Adjacent digits alternate between odd and even parity. Modular teal. Every set of three sequential digits contain one digit from 147, one from 258, and one from 369. Finally, entropic orange. Every set of three sequential digits contains one digit from 123, one from 456, and one from 789. Okay. So you just solve it, but when you get stuck, I can add clues. So let's do an example of each of these. Green lines is driven whispers. This means that, say you have a cell of size 1, then the cells next to it have to be at least 5 away, which could be 6, or you could have like a 6 or an 8, something like that. Thermometer means that you have digits that increase from the bulb to the tip. So you can have 1, 2, 5, and 8 is a valid thermometer. You couldn't have 1, 2, 2, for example. But then again, that repeats, so that you couldn't have 1, 2, 1, 5, 2, because that goes downwards. And you couldn't have, well, actually, yeah, you couldn't have like 1, 2, 2, or you couldn't have 2, 5, 1. Those wouldn't be valid thermometers. 2 and 8, this just means that there's a 2 and an 8 somewhere in these 4 cells. It could be 2 of those 4 cells, but it has to be at least 1. Renban, you could have any 4 digits that are consecutive, so you'd have like 3, 4, 5, 6 is a valid Renban in any order. Between lines, this could be like 1, 4 or 1, 5 with a 2, 3 between them would be valid. This means that whatever these add up to would be the same on both sides. This is a 10 line, so that means that you could have 1, 2, 3, 4 adding up to 10, or you could have like 1, 9, 2, 8s. This is Nabner, I think. Is this that type of yellow line, or is this a difference? Yeah, this Nabner is gold, and Entropic is orange. And they're in order, so it's probably that, yeah. Nabner means that you could have something like 1, 4, 6, and 8s would be valid Nabner line. You could not have the 1 and 2 on the line, because those would be consecutive. Parity means that if you have a 1 here, the other one has to be even, so you could have 2, and then like 3 and 6 would be valid Nabner parity line. Modular means that one has to be from 147, another from 258, another from 369. And entropic means one from 123, one from 456, one from 789. It doesn't have to be in that order, but you have to have those three in some order. Okay, let's get into it then. First thing I saw is this one. It's 3 lines adding up to 1 line over here. 3 digits over here adding up to 1 digit over here has to be at least 6, 7, 8, 9. And that's the first thing I saw. Let's see, what else can we do here? These two have to have the same entropy, so it's either both lows, both middles, or both highs. It cannot be both lows. There's a specific reason for that. If these were both 1, 2, 3, then you can only have 1, 1, 2, or 3 over here. The other two would have to be 4 and 5 at least. 4 and 5 plus 1 is 10, and that's not Sudoku digits. So one of these is a 1, 2, 3, which means this is no longer a 6, because that would have to be 1, 2, 3. These do have 2 of the digits from 1, 2, 3 on it, though, and the third one is somewhere over here. Oh, hey, Raffings. Welcome. This could be both 7, 8, 9, though. And then we have a 4, 5, 6 over here. Or they could be both be 4, 5, 6, and this would be 7, 8, 9. Both seem to work. What about this? This one couldn't be one single thing over here for a 10 line. It couldn't be 1, 2, 3, 4. Otherwise, the low digits on this German whisper line would be broken. So it has to be 2 10 lines. Because it couldn't be 3 and 1, because 1 cannot equal 10. 1 digit cannot equal 10 in Sudoku. So none of these contain a 5. None of these contain a 5, because 5 and 5 would have to equal 10. So this is a 5 over here. If these do not contain a 4, 6, then this is 4, 6, 1, 9, making this a 2, 8, 3, 7. Otherwise, it can be a 4, 6 with anything else over here. This can be as little as 4. That's not really constrained. Ah, this though. With Renban lines, if it's an even length line, that means that there are going to be the same number of odds and evens on that line. Because you have if you have like 1, 2, 3, 4, then that's 2 odds, 2 evens. And it's going to be the same no matter how you do it. Because if you had, like, say, for example, 3 odds on here, like 1, 3, and 5, How are we going to bridge between all of those? You can't. So these are going to have 2 odds and 2 evens. This parity line is going to have 2 odds and 2 evens, which means this cell over here has to be odd, because there are 5 odd digits and 4 even digits in a Sudoku. 2 here and 2 there are the even digits. Okay, that's not really helpful. It's 1, 3, 7, or 9, we know that. Three's in one of those cells, eight's in one of those cells, two's in one of those cells. Which means that 2 can't be here. We know that. So 2 could be one of those cells, and one of those would be 1. If 2 is here. If 2 is here, 1 would have to be there. And this could be like a 1, 3, 4, 1, 3, 5. Hmm. 9 is in one of these cells. If it's here, it's with a 1. Otherwise, it's not constrained over here. Five is definitely on one of those lines. It's actually it's on all these lines somewhere. Not all of them, but on a choice between the 2 of them looking at each other. Hmm. Not sure where to start this puzzle besides these 2. But I'm not sure where to continue this puzzle. I'm thinking the number is pretty constrained. Because the max you can have on a Nabner line is 1, 3, 5, 7. With a 4-cell Nabner line, though, you have a little bit more choice. You have 1 degree of freedom. Well, 2 degrees of freedom. Because you could have 1 from 1, 2, 3, 1 from 3, 4, 5, 1 from 5, 6, 7, and 1 from 7, 8, 9. Those are the possible numbers on a 4-cell Nabner line. And if the highest one is a 7, that's very forcing for these because it makes it a 5, 3, 1. If the lowest one is a 3, that's very forcing because it makes it a 5, 7, 9. If there is a 2 on the line, it has to be over here. Reason why is because in these 4 cells over here, in these 8 cells, or in these 2 columns, you have 2 2s already. 2 2s and 2 8s. And so in nowhere else in the column can you have a 2 and an 8s. Same for 8s in these rows, same for 2s in these rows. Hmm. This one certainly is a toughie. What can this be? The highest number can't be a 4. Because if this were a 2, 3, the only low number on this thing could be a 1. So the highest number has to be at least 5. Lowest number can be 1. And of course you could just have like a 9876. I don't think the modular line is very constrained. 147.258.369. If this were over here, that'd be really good. Because then you'd have a 258 only being able to go into one of them, and then these cells would have to be 258. However, this is not a 258, so that's not really worth thinking about. Hello, welcome to the stream. Watch me suffer as I torture myself with amazing puzzles. Hmm. It is. It's a lot of colors. And very symmetrical grid. We have all the lines pair up perfectly with the other lines, as well as the quads pairing up perfectly with the other quads, just on a 180-degree angle or a 45-degree angle. Well, no, it is 180 because you reflect it 180 degrees, and then it's going to be the same thing, just different colors and different numbers in the quads. Huh. If I went down here, this would either have to be 1, 2, 3, 4, or 6, 7, 8, 9. It's not really interesting. Hmm. If this is a 5, it couldn't contain a 4 or a 6 on it. So you could have 1, 3, and 1 from 7, 8, 9. Or 7, 9, and 1 from 1, 2, 3. On the other hand, if this is a 5, then this is a 1, 2, 3, 4. If 8 is one of these, if this is a 4 stays up here with a 1, 9 over here, then 8 has to be one of those and 2 has to be one of those. Making that a 2, making that a 2, making that a 1. Which makes this the 3, 5, 7, 9. Ah, there we go, that's broken. Okay. 4, 6 cannot be up here. Because if this were a 4, 6, making that a 1, 9, this has to have an 8, 2, and a 3, 7 on it to make up the two other 10s. The 8 cannot go in these rows because there's S wing over here. So it has to go up here, and the 2 that joins with it to make 10 has to go over here. That makes this have to be a 2. This has to be a 2, and this has to be a 1. Which makes this 3, 5, 7, and 9. But this one now has to have an 8 as well. Whereas the 8, it can't go over here, it has to go over here, which makes this an 8, and this a 9, making 2 9s clash in the column. Therefore, forces cannot be up there. Forces has to be down here, somewhere. And that's something. It's more than nothing. Although, now, that does mean that 3 cannot be the lowest number on here. Because if 3 was the lowest number on here, this would be 3, 5, 7, 9. And you would have to have 2, 8 over here, making that a 2, 8, making that a 1 and that a 9, which would break. So 3 cannot be the lowest. And I think 7 can't be the highest for a similar reason. Because if this were 7, it would be 7, 5, 3, 1, making that a 2, 8, making that a 2, 8, making that a 9, 1. And the ones would clash. Ah, yes! Perfect! Okay, this is the next step. This was completely unnecessary over here. That was too much thinking. Instead, what I should have thought of is, can this be a 2? Or can this be an 8? Either way. If this is a 2, that makes that a 1. And then what can this napter be? The lowest digit you can have is 3. That makes this 3, 5, 7, and 9. Which would make this a 2, 8 pair. So the 8 has to go here, making a 9 there, which would break, because there are 2 9s in the column. On the other hand, if this is an 8, that makes that a 9. And the highest it can be is 7. So then you have 7, 5, 3, 1 as that napter, making that a 2, 8, which makes that a 2 and that a 1, having 2 1s in the column, breaking. Therefore, 2 and 8 cannot go on this side over here. They have to go over here, which makes this over here a 2, 8 pair and a 5 there. That's the next step in this puzzle. Now, neither of these can be 2, 8, so 2, 8 has to be up here. 2 being there, and 8 can be there or there somewhere. We cannot have a 4, 6 here because there has to be a 2 somewhere up here. And the 2 can't go here because of that. There's a 2 X-wing over here. 2's there, by the way. Oh, since 2 is there, that makes that a 1. But now, 4, 6 can't be up there, so this has to be 4, 6, and something else. Okay. This cannot be, it cannot have a 7, 9 on it. It cannot have 7, 9. In fact, it cannot have 1, 3, 7, 9, or 2, 8. So the other two have to be 4 and 6, because it cannot have a 5. 5 is consecutive with 4 and 6. The rest of the digits in this row are 1, 3, 5, 7, and 9. This is not a 5, this is not a 1, so this has to be 3, 5, 7, 9, making that a 1. This 2 over here makes this either a 1, 3, 4, or 1, 3, 5. Definitely a 1 and 3 on it, which makes this an 8 or 9. Now the slow digit over here has to be a 2, And 9 is not over here. Could still be here though. The one there. 7's not over here. Ah, there we go. This one has to contain a 7 or a 9, because it cannot contain a 4 or 6. So this one over here has to be a 7 or a 9. Making this a 2. That an 8. And this a 1, 3. The other one that has to add up to 10. 7, 9, 1 or 7, 3. 8 goes here, 2 goes here, 2 goes here by Sudoku. 7 goes here now. This 4, 6 makes this have to be a 4, 6 up here. Because both this one could not be a 4, 6. Breaking that cell over there. This is the other of the 1, 3 or 7, 9. 1, 9 or 7, 3, 7. Where does 7 go? One of these two cells. 9 is one of these two cells. It can't go here because 9 cannot be on a between line, same as 1. This has to be at least a 6 because there's a 1, 3 here. This is at least a 4. However, if this was a 4, this one couldn't be a 5 because then it would break this cell, these pairs of cells over here. So this has to be 6, 7, or 8. 1, 3, 4, and 6 to go over here. This is 2 8s and 7 9. This is 1 9 3 7. This over here is a 5 somewhere. Where does 2 go in this box? Because there's a 2 over here and a 2 over here, that makes an X-wing, which means the 2 can't go over here and can't go there. So it has to go in one of those two cells. These two could be 4 7 or 5 8s or 3 6 9. But this one would have to be 3 9. What can this red band be? Where does this 9 go in its box? It can't go on the red band because if it was on the red band, it'd have to have the digits 9, 8, 7, and 6. But then where does 8 and 7 go? They can't go in any of these cells in the box. They would both have to go here. This is not a Schrodinger cell puzzle. So the 9 has to go here. Make the 9 go here in that box. This is not a 5. This is 1, 3, 4, 6. This could still be like a 6, 7, 6, 5, 4 red band. It's the highest it could be. Or it could be a 1, 2, 3, 4 even. But it cannot have a 9 or an 8 on it. 9 goes in one of these two. So this is not 3, 6, 9. This is either 4, 7 or 5, 8. One of these two is a 3. The 3 can't go there, so that's a 3. This is a 1, therefore. This is 3, 4, 6. 3 can't go there. This is not 1 or 3. This is a 9 now, making this a 3, 7. This is 1, 9, 5. This is 2, 8, 7. This is an 8 now, because the 9 is looking at it, making this a 1, 3, 4. This is either 7, 9 or 5, 6, in that order. This is either 4, 6, or 7, 5. This is either 6 or 7, 9. 6, 7, or 9. This is 3, 7, or 9. Ah, 9 goes in this quad, so it has to go here. Making that a 9. Where does 9 go in this box? Let's go in those two cells. This is not 9 anymore, which means this is not a 7. This is 5, 8, or 4, 7. 4, 5, 7, 8. This one can be a 5, 6, or 7, but it can't be a 7, so it's 5 or 6. These are all 5, 6, 7, or 8, which means 7, 8 goes here as a pair, making that a 5, 6, which just means this is not a 6. This is 1, 3, or 4. This is not 8 anymore, which means this is not a 5. Five, 8 makes that a 7. 4, 7 means there's already a 7 there, so this is not a 7. One can go into any one of these 3 cells. This is not an 8. One of these cells contains an 8. Most likely this is going to be an 8, and this is going to be an 8 over here. Otherwise, I don't really see a reason for the 8 to be in this quad. This cannot be a 7, otherwise the high digit over here would be a 9. This is either 2, 5, or 7. And this is the other one is either 5, 6, or 7, 9. Hmm. Four goes in one of those cells. It's not really interesting. There definitely is a 4 on this line. That's for sure. Which means these have to be 2, 6, 8. Two choices from that list. There's definitely an 8 though. Which means the 8 either goes here or here. If you want, maybe that's why this has an 8, 9 in it. Yeah, that could be the case. So this could be an 8, making that an 8, making that an 8. Two, 4, 5, 6, 7. Not really worth pencil marking. I got the quads, except for that one. Rentman's done. No, sorry. Thermometer's done. Whispers are done. 10 lines done. Manometer's done. This is done. Just have these 5 to go. One of these is definitely a 9. If that's 9, that's an 8. If this does not contain a 2, if the 2 does not go there, then the 2 would go over here with the 8s. There would be both a 4 and a 6 over here, making a 5 also go over there. Five is definitely one of those two. Might be worth pencil marking. 5, 8 makes 6, 7. Then what's left in the row is 3. In fact, what is left in the row? 4, 5, 6, 7, 8. This is a 3, no matter what. There we go. That's something. Here goes down here. Two, 4, and then one choice from 5, 6, 7, and 9. This is definitely a 2 and 4. One of these is definitely a 4. But I could have told you that before. Whereas 4 is row. Can't be there, can't be there. Has to be there. 4 can't be there, because there definitely is a 4 on here. If there are any even digits over here, it has to be a 6. Otherwise, they're both odd. Quite odd indeed. This is not a 4, because there's a 4 looking at it. If this is 1, 2, 3, 4, then 1, 3 go here. If this is a 6, that's an 8. This is a 7, that's a 3. Ah, there you go. If this is a 6, that makes that a 5. Because they have to be the same entropy on the orange line. That makes that a 7 and that a 4. So you have 6 and 4 staring at that cell, which is impossible. So this has to be a 7, that has to be a 9, this is a 6. This is now 2 and 5. That's a 3, that's a 7. 7 goes in one of those two cells. This is no longer a 5, this is a 4-8 pair, making that a 7, that a 5, that an 8, that a 4, that a 4 and a 6 and a 6 and a 4, that a 6 and a 5 and an 8. This is 2, 4, and 7. This is 1, 3, and 6. 8 now has to go here, which makes this not an 8, which makes that an 8, which makes this a 1, 3 pair, which makes this a 2, 7 pair, and that's an 8 now. What next? There's a 1, 5, 6 over here with the 2 and 9. This could still be as much as 7, 6, 5, 4, or as little as 1, 2, 3, 4. I'd love for there to be a 1 over here, because then you'd have 2, 3, and 4, but the 2 over here would make that 7 and a 4. And that'd be great. I mean, I can already tell by, what's it called, by uniqueness that this can't be a 2, 7. I'm not going to use that. This is 1, 3, 4, 6. Ah, yes. Not only are there 2 evens and 2 odds here, they have to alternate parity. So this is odd, this is even, this is odd. This one cannot be an 8, cannot be a 2, because there are 2 2's x-wings looking at it. Cannot be a 4, because the 4 on this line, so it has to be a 6. In fact, I could have said before that there has to be an even somewhere over here. I did say before that if there was, it'd have to be a 6. But I could have said before that there has to be, but these can't both be odds because they have to modulate between polarities. Anyway, so this is a 4. This stuff has a 3 and a 5 on it. Sorry, a 3 and a 2 on it. Could be 1, 2, 3, 4 or 2, 3, 4, 5. But the 2 has to go over here. This is either 1, 3, or 5. This is not a 2. This one is a 2. These are 1, 5, 7, and 9. This is not 9. This is not a 7. This is a 1, 5, 9 as well. None of these are 5. There's the 5 over here. which makes this a 7, this a 1, 9 pair, this a 5, this a 1, this a 1, this is a 3. 3 goes in one of these two cells. In fact, we have 3, 4, 5, and 8 are the last 4 cells in that box. This is a 2, this is a 7, this is a 4, this is a 2, this is a 7. We have 4 and 6 to go in that row. And we have 5, 7, 9 to go in this box. This is 1, 3, 4, 5, 6, leaving 7 and 9 to go here. This is now a 3 and a 5. This is a 1, 6 pair, making that a 4, that a 1, that a 4, that a 6, that a 3. And now we just have these to differentiate. Where do we do that? Where do we do that? Did I mess something up? Huh? 2, 3, 5, 8. 2, 4, 5, 8. 1, 3, 6, 4, 8. And 1, 3, 6, 4, 5. Oh no. Oh, there's 2 5s in this row. There's 2 5s in this box. That's where I messed up. Okay. I accidentally put that as a 5 instead of a 4. There we go. Thank goodness. 2, 7. This is 5, 6 now. Make that a 5, that is 6. And then we have 4, 7, 9 to go in this row. This then to finish off. This is not a 3, this is not a 6. This is a 7, this is a 9, this is a 9, this is a 1, this is a 3 and a 5. This is a 4, that's a 1, that's a 1, that's a 3, that's a 3, that's an 8, that's a 4, that's a 5, that's a 5, that's a 2, that's a 2, and that's an 8. And then we have oh, there we go. Yet again, I break it because I put 1, 4 instead of 1, 6. 6, 1, 1, 4, 4, 6, 3. And that is the finished puzzle. Whew. Thank you, thank you. That was a workout. Now, I may have broken it twice, but those 2 breaks were from typos. Therefore, I don't count them. Thank you all. Well, time for the next one. Large grid with arrows. 1 cell equals 1 stream. Draw a non-intersecting orthogonally connected loop through the centers of some cells. Every cell in the grid is one of the 3 types: fully inside the loop, fully outside the loop, or part of the loop. A 2x2 area cannot be entirely one cell type. Cells inside the loop form one orthogonally connected area, and cells outside the loop are orthogonally connected to the edge of the grid. A number with arrows indicates the total amount of cells of its own type, not including itself, in those directions combined. Okay, so we have a loop puzzle with arrows. And every cell inside the loop is a cave cell, and every cell outside the loop is a wall cell. So it's basically just a cave puzzle with a loop distinguishing it and arrows. Okay. Let's say what each of these rules mean. So we have a non-intersecting loop, which means that the loop cannot do that, for example. Orthogonally also means that it cannot go diagonally like that. It has to travel between cells adjacent to them, orthogonally adjacent to them. And with this, cells outside the loop have to form wall cells touching the edge of the grid, and cells inside the loop have to form cave cells inside the grid that are all connected. So it cannot do something like this. The reason why, because first of all these wall cells have a 2x2 in them, and a 2x2 area cannot be entirely one cell type. Which means also that you couldn't have something like this, because that's a 2x2 of loop cells. This means that this means that a loop cannot touch itself orthogonally unless it is something like that. That's the only way for it to touch itself orthogonally. But also, all of these cells inside of it would be 2x2s as well. And clues, is it, are arrows combined or in each direction? Oh, they must be combined because this is only one cell. Clues tell you how many, oh my gosh, I'm so bad at drawing this stuff. How many loop cells are in each of the directions combined. So this means that in these two directions, there are only 2 loop cells that visit these cells. Of these 5 cells, only 2 of them are visited by the loop. Okay? Cool. Well, let's get started. I am going to draw the loop as a red thing. The outside wall cells is shaded, and the inside cave cells as green. This means that there are no loop cells over here. And because it's touching the edge of the grid, it cannot be inside of the loop. Otherwise, the loop would have to somehow go outside of the grid and envelop it, which is impossible. So this is a wall cell. All of these cells are going to not be on the loop. So I'm going to draw that as blue, as not on the loop. And then wherever the loop goes, I will change it to either shaded or green. Same for this, these are all blue. These are all blue, so are all of these. What's the point of this if this is also looking that direction? Oh, of its own type, not of a... Okay, I see. I see now. It's a little bit... Okay, I see. This cell, then, is extremely restrictive. I should have been able to tell that this one cannot be looped to begin with, I don't think. The reason why this isn't loop is because if this was loop, there would be no loop cells in any of these directions. But that means that there are also no loop cells in this row, because in order for there to be a loop over here, it would have to come outside of that area. It would have to take the second row as well. But now that there is no loop in here, the loop is entirely inside this region over here, these rows over here, which makes all of these cells have to be outside the loop. But then you have a bunch of 2x2 areas of shaded cells, of wall cells. So this cannot be a loop cell. Can it be an inside cell? Or can it be an outside cell? If it were an outside cell, none of these would be outside cells, which is impossible. Yes. First of all, let's just say that none of these over here, on the edge of the grid, can be inside cells. Because in order for anything on the edge of the grid to be an inside cell, the loop would have to somehow come outside of the grid and circle it, which is impossible. So, if this were an outside cell, this means that this one cannot be an inside cell, cannot be an outside cell, so it would have to be part of the loop. In order for it to be part of the loop, it would have to do this. And no matter where this loop goes, in order to connect back up to itself, this cell over here is going to be inside of it. But we're saying that it's an outside cell, a contradiction. Therefore, this cannot be an outside cell. It cannot be a loop. It has to be an inside cell. In order for it to be an inside cell, the loop has to go here. None of these are inside cells either now. What does that mean? Surely that means that this one has to be a loop. Because if it wasn't, the loop would go here. In order for this to not be an inside cell, the loop would have to somehow come back to over here and do that, and that's a 2x2 of loop. So the loop has to go here. Same this way, in this direction. Now these are outside cells, because otherwise you would have loop cells doing that. In order to stop a 2x2 of outside cells over here, one of these must be part of the loop. In fact, actually, scratch any of what I just said. None of these cells now in the first row can be loop cells. Because if they were, then in order to prevent a inside cell from forming inside the loop, you would have to do this. But then that's a 2x2 of loop cells, which is impossible. That means that all of these in the first row have to be outside cells now. This one cannot be inside, but also cannot be outside, because if this were outside, then this over here would need to be part of the loop. It couldn't be inside because it's on the edge of the grid. And it couldn't be outside because then there'd be 2x2 of outside. But then in order for it to be part of the loop, it'd have to go here. So this is always loop. I'll make loops red. This can either be outside or loop. This is not inside cell, not outside cell, so it has to be part of the loop. This is not outside, it could be inside, or it could be loop. If this were loop, then there would have to be two loop cells over here. They couldn't be by themselves, otherwise in order to get out, they would have to turn in on themselves and create a 2x2 of loop. So the only way it would possibly work is if it was over here. But then these two are outside cells. And then that creates a 2x2 of outside cells. So then this cannot be loop. This has to be outside. And that makes it one more outside in this area. This one is loop now, because otherwise there'd be 2x2 outside cells. And this couldn't be outside, otherwise this would be loop. And it wouldn't be able to turn the corner. So that's loop, and that's the outside cell. This has to do that, so that's loop. This one cannot be a loop cell, as there would be a 2x2 of loops over here, so this is inside. All cave cells are connected, orthogonally connected, so these both have to get out. If this were part of the cave, it would make these two have to be... Oh, there we go. If this is a cave, then in order for the cave cells, there to be two cave cells in these two directions, they have to be over here, with the loop enclosing it. But then you have a 2x2 of cave cells. So it could be loop, with loop coming down this way or that way, or we're doing something like that. Or it could be outside, with these two being outside. In which case, this would be loop. In fact, if this is loop, now you can still do that, and do that. This is not outside. It could not be loop. If this was loop, none of these would be able to be loop. But then how would you, what would you do to connect the loops? They would have to, at most efficiently, do this. But then you're left with a bunch of outside cells over here that create 2x2s. Therefore, this one has to be inside a cave cell. There are no caves over here. There are no caves in Ba Sing Se. I think that means that this one cannot be. No, this one has to be, in fact. This one has to be a loop. I see how it works now. Okay. First of all, this one has to be inside, because otherwise it'd be a 2x2. This one has to go there. And now how do you stop this from being a cave? It has to be a loop cell. Now this cave has to get out. This one has, the loop has to come this way. This could still do that, and I could do that, or even that, for example. Although, if I did do that, and this is something like that, then this wouldn't be inside the loop. If this went here, how could both of these be inside the loop? Because on either side of a loop segment is going to be either a loop cell, or if there are no loop cells on either side of it, then one side is going to be inside the loop, and the other side is going to be outside the loop. Therefore, if this went here, then both of these could not be inside the loop. That's impossible. So that can't go there. This has to go up here and there. Now, because this is inside the loop, this has to be outside the loop. This has to be inside the loop now. If this went here, that would also go there and create a 2x2 region. This has to be outside the loop. Otherwise, it would create a 2x2 region of loop. This has to go there, making that loop. This is outside the loop, so is that. Yes. This has to connect to the outside of the grid. And if it doesn't connect through there, and if this does that, then how is this going to get to the outside of the grid? Wherever it goes, it's going to break off this loop segment from the rest of the loop segments on the other side of it. So this has to go there. This one has to go here. This goes here, has to get out. This is not loop. It could still be outside, and it could be inside. If this wasn't cave, then it would have to be loop. So this is either loop or cave. If it's cave, and those two are cave, and the loop goes there. Oh, this can't be cave. We said this before. This cannot be cave. Because otherwise, these two would be cave, and they'd be 2 by 2. Therefore, cave goes this way in order to get out, and this has to be loop, and so does this. Has to be loop. Cave has to get out this way, so that's loop. Loop is like that as well. Has to get out. Cave has to get out, so it's loop. This and this, these are both outside cells. This, and the reason why that's an outside cell is because if it wasn't, then we have the same problem with the outside cells and loops. We cannot have a checkerboard patterns of inside cells and loop or outside cells and loop. Otherwise, it would break. The checkerboard, this thing would have to get to the edge of the grid, and it would cut off the loop from the rest of the loop on the other side of it. And if it was green and loop, then this green has to connect to that green somehow. And in order to do that, no matter which route it took, it would separate that side of the loop from that side of the loop. So we cannot have checkerboard patterns in this loop puzzle. That has to get out, so does that, and so does that. This could still be outside, cannot be loop, and it could still be inside. This has to be loop now to avoid a 2 by 2. These are inside the loop, or this is inside the loop. Does this have to be inside the loop? Oh yeah. This cannot be loop, I don't think. Otherwise, how's it going to connect? How's that going to connect to that? It cannot without making this be inside itself. So that's loop, inside loop, that's inside loop as well. What's this? Or this? This cannot be loop. If it was, then how would this get out without taking out those two cells? It's impossible. Can it be outside? Yes. Can it be inside? Hold up. I am being called by my brother. Bear back. Sorry about that. My brother had interest questions, as in which bank to choose, and he got confused. Anyway, let's go back to this. Where was I? This will connect to this, either here or here somewhere. One of these is definitely taken by this. Oh, cool. Yeah, I'm having fun with it so far. I like these 3-cell puzzles. 3-cell cave puzzles, basically. If this is outside, then this one would have to be outside clue, making that be forced. If this were inside, in fact, this one could not. No, could. If this were inside, it would have to be that being the inside, and that would have to be the. This would have to do this. So either it's outside and this does this, or it's inside and this does this. But either way, these two are taken by the loop. And thus, in order for this to connect to the rest of the grid, it has to do this. This, in order to get out, has to do this. And this is now an inside. There we go. So this is the inside. This is the loop. And this has to be outside. This is loop. These are all now inside the loop. This is a loop cell, which has to do this. And now that. This is a loop cell. This is an outside cell to avoid 2x2 over here. This is an outside cell to avoid 2x2. This is also an outside cell. If this were an outside cell, then this would also have to be an outside cell. So this would be a 2x2, so this is a loop cell. So is that. Has to do that. If this went here, then this would. If this went here, if this loop cell went here, it couldn't go back up here, otherwise it'd be a 2x2. But there cannot be any loop cells over here. So it'd have to go down here, but then how is it going to get back up above that row? It has to cross somehow. That's not possible. So that one has to go there, which has to do that now. This one has to be inside, so none of these can be inside, which means this one has to be loop. Now none of these, same reason for over here, can be loop. Otherwise, in order to get back up, it would either have to create a 2x2 of loop or create an inside cell. So these are all outside cells. Now this cannot be a loop cell, because if it were, then there would be no loop cells and no green cells over here. So these would all be outside cells, and there'd be 2x2s of outside everywhere. It cannot be a green cell because there's no green cells over here, so it has to be an outside cell, making these two loop cells, which have to do this. Oops. Also, all of these are loop cells, because all of these are loop cells, because they cannot be green or outside. This one has to go to this, otherwise it creates two 2x2s over here. These are both inside cells. This has to do that. This, if it went here, this could do that. Maybe, no, this one has to do that because this has to get out. And these two cannot create a 2x2 of loop cells. These are all loop cells now. These are all inside cells now. This is a loop cell. This is an outside cell. Oops, wrong color. These have to do this. One of these is a loop cell, because otherwise there'd be a 2x2 of green in here. And the other is green. If this were loop cell, that would be the case. If this were loop cell, that would be the case. This is either inside or outside. This could be outsider's loop. What's it using? Oh no, it's 5 years. This one, it cannot go here. This has to be inside. This has to be loop. So these two connect. These two are inside. Now this is a loop, and must do this. These two have to connect now. This one does that, and has to connect over here. Could this be outside? Maybe. No, because this has to connect to that over there. Yeah, this has to get out. This loop has to get out. So does this. This has to reach the edge of the grid somehow. This has to get out. This has to get out. It does this now. These are all inside the loop. This has to do that. These have to get out. It's the edge of the grid. This one has to do this. Now these are both outside, so are all these. This is loop now. This is inside the grid. This has to get out. This cannot go there because this has to escape somehow. So it must do that. This has to connect to his friends. Oops. That has to go there, that has to go there. Connect to its friends. Has to go there. This has to go there. This is outside the loop, so is that. And that has to do that. That is the finished puzzle. Nice. 34 minutes isn't too bad. I like the shape that it makes. It's a pretty fun shape. I wonder what the 1 cell equals 1 stream means. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 200. Maybe this is their 200th puzzle? I don't know. Yeah, I liked it. Alright, time for the next one. Nabbed by MathPesto. Normal Sudoku rules apply. Each purple line contains a set of non-repeating consecutive digits, not necessarily in order. Each gold line contains a set of non-repeating digits, and no two digits on a gold line can be consecutive. Okay, so we've been through each of these before. A rand band line means that there's consecutive digits. You can have like 3, 4, 5, 6, 7, 8, 9. Could be one example of this 7-cell rand band line. And a Nabner line means that no two cells can be the same or consecutive. So if this were a 1, this could be a 1 or a 2. Let's get into it. This is a 3, so this 5-cell RAM band has to contain at least 5, 6, 7, and 8 on it, and 1, 2 go here, with either a 4 or a 9. This 7-cell RAM band has either 1, 2, 8, or 9 missing. 1, 2, 8, 9, or 1, 9 being the options for that. 1, 2, 3, 4, 5, 6, 7. Okay, this one, 7-cell RAM band, also has 1, 2, 8, or 9 left out. And this 7-cell RAM band, as well as that one, has 1, 2, 8, 9 left out. This is a 1, 2, 8, 9 triple. Quadruple, I mean. So the rest are 3, 4, 5, 6, 7. Not really interesting. These ones look pretty restrictive because there are 4. And they have 2 end digits missing. So if this is 1, 2, this is 3, 5, 6, 7. Sorry, 3, 5, 7, 9. If it's 1, 9, it's 2, 4, 6, 8. If it's 8, 9, then it's 1, 3, 5, 7. So either they're all even 2, 4, 6, 8, or they're 1, 3, 5, 7, or they're 3, 5, 7, 9. So either they're even or they contain 3, 5, 7. That's what I'm saying. This one is 3 consecutive digits, with 2 of these being non-consecutive. That means that this one is the middle digit between these 3. So if this were 1, 2, 3, that'd be a 2 with these being 1, 3. Let's need a note. This one isn't as restrictive. Oh wait, yes it is, because this is also 4. These are all 4. If this was 1, 9, these would be 2, 4, 6, 8s. Which means that these ones would be 3, 5, 7 with a 1 or a 9. Is that possible? Probably. This is any number between 2 and 8. Not really worth noting. These definitely have a 1 and 2 on them. In those 3 cells. These are definitely 5, 6, 7, and 8s on there. If this is 2, 4, 6, 8, yes. If this is 1, 9, whichever one is 1, 9, if there is a 1, 9 here, it makes every single cell that's a part of it even. So if this is 1, 9, these are all even. And if these are not 1, 9, then they're either 1, 2, or 9, 8s, which means every single one of the things on them are odd. So if this is a 1, 9, these are both contain a 2, 8 there, which means these are all odd. These are both odd. However, since these are all even, that means that these are also odd. And how many odds do you have in that column? 1, 2, 3, 4, 5, 6, which is impossible. So this is not 1, 9. It's either 1, 2, or 9, 8s, which means that these are all odd. And it does have an odd here, so these are all even. Now, can all of these have a 2, 8 on them? If all of these are 1, 2, and 9, 8s, one of those two, then these are all odd. And then you have even, even, even. That works. Or all odd here, all odd there, all odd there. Then those are all even. 1, 2, 3, and then 4 with one of those, and a 4 with one of those. Does that work? Question mark? I don't think it does. 1, 2, 3, one of those has to be even, making the other odd, making one of those two even. 1, 2, 3. Oh, no, that works. Can any of these be 1, 9? If this is 1, 9, those are all even. Making all the evens taken up in that row. Which means all of these would be odd. But then those all would be odd. And where are all the evens in that? That would have to be a 2, 8 pair, which is impossible. So those can't be 1, 9 either. This has to have a 2, 8 in it. which means these are all odd. These are all even. I think the same logic is going to apply over here. Because if this is 1, 9, these are all even. Oh yeah, this already has this there. That's an even. Those two are even. So you can't have 5 evens in that column. So this has to be 1, 2, or 8, 9. And these are all odd. These are all even. All of these contain 3, 5, 7. Which means that these are 3, 5, 7. Oh, these are 4, 6. I could have known that because of this, actually, but yeah, whatever. It happens. Bro, this dog. Again, she barks. She yelps. She cries for help. She needs to hurry up and get potty trained. She's the cutest dog, too. She's so cute. I just wish she wasn't so loud. What else can I clean besides that? If this were a 1, that would also be a 2. Because this is 7 long. If this were an 8, then it could be a 2 or a 9. If it were a 9, it would be an 8. And if it were a 2, it could be 8 or 1. There definitely isn't even over here, though. One of those two is even. This has a 5 on it. Ah, yeah. This has a 5 on it. So where does 5 go on this line? It can't go there. It can't go there, so it has to go in one of these cells. If it goes on one of those two cells, then those are 4, 6. Otherwise, it's less restrictive. This cannot contain a 5 on it. So either it's 1, 2, 3. It can't be 2, 3, 4. Either it's 1, 2, 3. Or it's 6, 7, 8, or 7, 8, 9. So this is 2, 7, or 8s. This is 1, 2, 3, 7, 8, 9. Are all the possibilities for that. If this were a 5, that would be a 4 and a 6. And then you have 3, 7 here. Actually, no matter what this is either 1, 2, 3, 4, 5, 6, 7, 2 8s, 3, 4, 5, 6, 7, or 9 8, 7, 6, 5, 4, 3. So this is always 3, 4, 5, 6, 7. And this has to be 3, 5, 7 then. This is 4, 6. This now can no longer be a 7. Neither can this, or a 3. So this is not 1, 2, 3 now. So this has to be 8 with the 7, 9 here. 7, 9 is resolved. This is a 7. That's a 3, 5. This can no longer have a 7 on it, so it does indeed have a 4, 3, 2 on it, with either a 1 or a 6 to complete it. Oh, but this is a 4, so that's a 6. That's a 4. This is 1, 2, 3, 4, 5. This now is an 8, 9. This is no longer a 1, 2. This is an 8, 9 as well. This cannot be a 1 or a 2, so it has to be an 8, 9. These are no longer 8, 9, so these are 1, 2s. So this is 3, 5, 7, 9, as well as this being 3, 5, 7, 9. This is 1, 3, 5, 7. The 1 cannot go over here because of the 1, 2 X-wing, or the 1, 2 pair. So that's a 1. One of those two is a 9. These are no longer 1s. So 1 has to go up here somewhere, which means that this is 1, 2, 3, 4, 5, 6, 7, with an 8, 9 pair here. This is not a 7. 6 is one of those two. This is 2 or 4. This is not 3 or 5. This is not a 7. These are not 9. So that's not 9. That is a 9. 6 goes over here. This is a 1, 2 pair. This is not 1 or 2, so these are 1 or 2. This is 6, 7, 8, or 9. This is not 7 or 9. This is 6 or 8. This one cannot be a 7 because that's connected to 6 or 8. So that is a 9 with a 6, 8. This is a 7. That cannot be an 8. This is a 8. Eight goes here now. The 4, 6 pair here. This is 2, 4, or 6. This is 4 or 6, but it is a 4, so that's a 6. That's a 4. This is a 2, this is a 6. This is a 4, this is a 6. This is a 4 now. This one is a 9. This is a 5. This is 7 and 8. One of these is an 8. This is not a 4. This is not 1 or 2. One of those two is 1. 6 goes in one of those two. 8 can go anywhere over there. Excuse me. 4 can go anywhere over there. Oh, this is a 2, 8 now. With that being a 1, that being a 1, that being a 2. This is a 9, this is an 8, this is a 9. 8, 9, 8, 7. 8 goes in one of those two. 9 goes in one of those two. 7 can go in either any of those three. 6 I already got. This is 1, 4, 3, or 5. This is a 3, this is a 4. This is a 5. This is a 7. That's a 7. This isn't a 7, so this is a 7-9 pair. Makes that a 6 because it can't be on the 7. The rest are 1, 2, 3, and 5. 3, 4, and 5. This is not 1, 2. This is not a 4. These aren't 1, that's not a 4. 4 goes in one of those two. 6 can go in any one of those 3. This is 1, 2, 3, or 4. This is 1, 2, 3, 4, or 5. Can't be 1 or 4, so it's 2, 3, or 5. This is not a 5, this is not a 3. 7 goes here. Goes in one of those two. This is a 6. That's a 6, that's a 9, that's a 6, that's a 7. 9 goes in one of those two. That's a 7, that's a 9, so that's a 9, that's an 8. 8. 1, 2, 3, or 5. 4 is one of those two. 2 is one of these two. That's not a 2. This is 1, 3, or 5. And come on, just the last thing to break this open. What is it? Question mark. This is 1. This is 2, 3, or 4. This is 2, 3, or 5. 1 is one of those two. There are no more Nabners. There aren't any more run bands. And this one is one more Nabner, but it's already done. Because 1, 3, 5 cannot be consecutive with 7 or 9. Oh, this is a 1. This is a 2. This is a 2. This is a 1. There goes Sudoku. That's a 3. That's a 2. It's a 3 and a 5. 1, 4, 5. This is a 4. 1, 5, 4. 4. 5, 5, 3. 1, 4. That's not a 1. These aren't 5. These aren't 5. This is a 5. This is a 1, 2, or 3. This is a 5. This is a 3 and a 5. That's a 5. That's a 2. That's a 3. That's a 1, 3, 2. 1, 3, and 2. And 3 and 5. Cool. Fun little puzzle. Nice little bite-sized snack. Let me turn my lights on real quick and I'll go to the next one. Oops, Daisy, don't do that. I've done 7 today so far, but I still have half of page 3 to do before going to page 2 and then page 1 afterwards. So on to the next. Gru, like green and blue, but also the character from Despicable Me. Normal Sudoku rules apply. Adjacent digits on a green line differ by 5 or more. Digits on a blue line have the same sum in each box the line is in. If a line passes through a box multiple times, each individual segment is summed separately. Okay? We've been over German whispers, we've been over these sums before. Region sum lines is the word. There we go. But not how dare you. Okay, so the first thing I look for in region sum lines is individual segments, and segment is a sum to 3. So this segment over here is equivalent to these 3, which can be at least 1, 2, 3, which means this is at least 6, 7, 8, or 9. On a German whisper line, that means this is 1, 2, 3, 4. Same for this one. This has 3 things over here, so this is 6, 7, 8, 9. This is also 6, 7, 8, or 9. And all these 3 segments are going to equal 6, 7, 8, or 9. Well, they cannot be 1, 2, 3. Otherwise, you have 1, 2, 3, 4, 5, 1, 2, 3s in this row, which is impossible. They also can't do the same for 7s. This is not 6 or 7. Oh, this one can be 6 or 7, though. No, it can't. In fact, this one, 1, 2, 3, 4, 5, plus at least 1 is 15 plus 16. So this has to be at least 8s. But it can't be 8s. Because if this was 1, 2, 3, 4, 5 with a 1, in fact, 1, 2, 3, 4, 5, 6 plus 1, 2, 3 is another 6. So 21 plus 6 is 27. Divided by 3 is 9. So this has to be a 9. And this is a 1, 2, 3, 4, 5, 6 with a 1, 2, 3 over here, which makes this a 4, 5, because that's the only way you can add up to 9 without using 1, 2, 3. These are no longer 4, 5 now, so this has to be 6, 1, 2. Excuse me. These are no longer 6. This one isn't a 1, 2, 3, has to be a 4, 5. This one has a 3 on it instead of 1, 5, or 2, 4. These are all 6, 7, 8, or 9. This is 7, 8, or 9 over here. This is now 1, 2, 3, or 4. Can't be a 5. How about this one? Does this one have to be 8 or 9? We have 1, 2, 3, 4, 5, 15, plus another 3, 1, 2, 3, 4, 5, plus 6, plus 1. 15 plus 6 plus 1 is 21, 22. 22 divided by 3 can be as little as 8, so it can be 8 or 9. I find it hard to believe that this can be an 8, though. 1, 2, 3, 4, 5 is 15 at least, which means this has to be at least 16. Can these both be 16 though? Can all of these be 16 in fact? 1, 2, 3, 4, 6. Is there any problem with that? Is there anything more than 5 here? 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2. Yeah, it's not possible. It's possible, I mean. Where does this 8 or 9 go in this box? Can't go on its own line, can't see itself. So there's either an 8 here or a 9 here. How about in this box? We know that it goes over here, in one of those two cells. So in this box, it goes in one of those two cells. We also know it goes in one of those two cells. It goes in one of those two cells as well. wakanayo. This cannot be a 1, 2 over here, because then this is at least 3, 4, 5. Which means this one is a 6. This one cannot be 1, 2. Now, if this were a 8, it would either have to be 1, 2, 5, which breaks that cell, or 1, 3, 4, which breaks that cell. So these have to be a 9. I can just get rid of that now. That's a 9. One of those two is a 9. This is either 1, 3, 5 or 2, 3, 4. This cannot be 1, 2, 6, cannot be 1, 2, 3, 4. It has to be 1, 3, 5. This is a 4, so this is 2, 3, 4. This is a 2, this is a 1. This is not 1, 5 anymore. Has to be 2, 3, 4. This is a 5, this is a 1, 3. This one is either 1, 2, 5 or 1, 3, 4. Or 1, 3, or 1, 2, 6 or 1, 3, 5, I mean. This is a 1, 8. Cannot be 2, 7, 3, 6, or 4, 5. Is that one that an 8? This is an 8. That's a 7 in that column. This is 5 and 6. This is a 7. Oops. That's 6 or 7. That's a 3. This is 2, 4, 6, and 7. This is a 1, 5, 6, 7. This is a 3, that's a 2. One of those is an 8 with a 4 or 6. This is 3, 6, or 4, 5. This one cannot be a 6, because then that would be a 1, this would be a 2, 3, 4, which is impossible. In fact, this cannot be a 3, 6 at all. If this were 3, 6, then this would have to be 1, 2, 6, because it has 3 there. But then there's the 6 clashing. This has to be 4, 5. The 9 there. This is 1, 2, 6 now. Cannot be 1, 3, 5 or 2, 3, 4. This is not a 4. This is not a 6. This is 2, 3, and 6, which means 2 and 6 are over here. This is a 3. 5 and 6 makes that a 6. That's 1, 2 pair. This is 7 and 8. This is 1, 5, 7, or 8. This is 3, 4, 7, or 8. Banana. This could... Hi, doggy. I might let the dog in.
Hmm?
Hi, doggy. Come here, girl. Good girl. Why does she smell like piss?
Well, she has poop on her face.
Ew. Go put her away. Don't let her lick your face. Anyway, this has a 1, 2, or 3 on it. So that makes a 1, 2, 3 triple. That's not a 1. This is not 1, 2, or 3. Has to be 5, 6, 7, or 8. 8, 1, 6 cannot be 6, 3, 7, 2, or 5, 4. This could either be 5, 1, 3, 6, 1, 2, or 4, 2, 3. So either 5, 1, 3, 6, 1, 2. The 6 couldn't go there because then the 1 would mess up the 1, 2 there. Or 4, 2, 3. That's not a 3. So this is always low, and this could be high with either 6, 7, or 8s. La-di-da, la-di-da. This is 2, 7, 4, or 6. And what can this be? Well, this is a 9 for sure. This is either 1, 2, 6, 1, 3, 5, or 2, 3, 4. 5, 1, 3. 6, 1, 2. This is always 1, 2, 3, or 4. It cannot be a 4, it cannot be a 5, it cannot be a 6. So this is a 6, 7, or 8. You know, it's funny you say banana, because I have a banana with me. Don't mind the ASMR if you hear me eating. Banana depleted. I always feel so weird about eating on stream. I'm not used to the ASMR stuff. I'd find it too cringe to ever be able to pull it off. What's next in this puzzle? If this is 1, 3, 5, then that'd be a 2. And it could be with 3, 4 there. Or 6, 1 there. Ah, ah, ah. No, that still works. If instead it was a 1, 2, 6, hmm. 1, 8 makes this 2, 3, 4, which makes that a 7. Oh, that's it. This can't be an 8. If this were an 8, that would be a 1. This would be a 2, 3, 4. This now cannot be an 8. It cannot be a 6 because there's no 1 here. So it'd have to be a 7, and that breaks this cell. So it can't be 1, 8. This now can no longer be 2, 3, 4, because that would break this cell. These are not 4, that's not 2. These two are 1, 2, or 3. Whatever this 5, 6 is, will go over here in that column. Because it can't go there, it can't go there, and it can't go those two. So it'd have to go there. There's definitely a 1 here. And either there's a 1 here, making that be a 1, or there's 2, 3, 4 here. Which I don't see if that is broken or not. If this is a 5, and this is a 6, 1, 2. If that's a 7, 2, that's a 1, 3, 5. So one of those two is definitely a 5. This one can definitely not be 1, 3, 5 now then. Because if this is 1, 3, 5, then where does 1 go in this row? It can't go there because there's 1, 3, 5 there. It can't go there because there's a 1 there. So that has to be 1. But now what about 5s? 5 can't go there because there's a 5 there, and 5 can't go there because there's a 5 in one of those two. So 5 and 1 both have to go in that cell, which is not a Schrodinger cell. So either this is 1, 2, 6, or it's 2, 3, 4. Either way, there's always a 2 here. And this is 5, 4, making that a 6, 1, 2, or 7, 2, making that a 2. So these always contain a 2 somewhere in that quotient of digits. Which means where is the 2 in this row? Can't go there, can't go there, has to go here. This is not a 4, which means the 4, 5, or 6 still go over here somewhere. But again, it can't be a 5, so the 4 or 6 goes over here, with the other 1, 2, or 3. Either it is 1, 2, 6, or 2, 3, 4. So this can't be a 6. If this were a 6, that would be a 1, 3, 5, which is impossible. This is 7 or 8. Porous, porous, pour everybody else. This is a 2, 4 pair, which makes this a 2, and that a 1, which makes that a 3, and that a 1, which makes that a 1. This is not a 3 anymore. 2 is one of those 2s, so that's not a 2. Three is one of those 3. These are not 1s anymore, so that's not a 1 anymore. This is not a 6. This is 2, 3, or 4. That's not a... That's... Wait, no, sorry. This isn't a 6. So that can be 1, 2. This is 1, 3, or 4. Either 1, 6, 2, or 2, 3, 4. Um... That's a 6. That's a 5. That's a 3. Uh, that's a 6. That's a 2, 3, 4. That's a 3. So one of those two is always a 3. Either this is a 5 and that's a 3, or this is a 6. This is 2, 3, 4. And then you have 2, 3, 4 pair here, making that not a 3. This is never a 3 though. If this is a 3, that's a 5. That's a 6, that's a 2, and that's a 4. But if this is a 3 and that can't be a 2, 4, then what is that? It would have to be a 1, 5, which would break over here. So this is a 2. Making that not a 2. Either have 1, 6, or 3, 4 here. Which means there is a 1, 3 virtual pair over here. So it's 1 or 3, 4. So this is not a 1, this is not a 3. There's also a 4, 6 over here. 2, 4, 6, 7. No, we don't have a quadruple yet. If this is 5, 4, that's a 1, that's a 3, that's a 4. Making that a 4. If that is a 7, 2, 3, 5, 3, 6. Oh, there's always either a 6 or here or here. Either this is a 6, or that's a 5. Making that a 3 and that a 3. And that's a 1, 6. So one of those two is a 6. Neither of those are 6s. I'm bad, you know it. Haha. 'If this is a 5, that's a 7, which means that is 7. If that's a 6, that's a 2, 4, making that a 4 and that a 3. That's a 7. Yeah, so either this is a 5, making that a 7, making that a 7. Or this is a 6, making this a 3, 4. But then that's a 2, that's a 4, which makes that a 4, 3. That 4 makes that a 7. So that's always 7. Five, 4. 5, 4. 3, 1, 6, 2. Yes. Yes. Where does 8 go in this row? It can't go here, it can't go there, it has to go in one of these two. So that's a 7. Where does 7 go in this row now? It can't go there, can't go there, it has to be that one. That's a 7, that's a 2. That's a 3, that's a 5, that's a 3. This is no longer 3, 4, it has to be 1, 6. That's a 1, that's a 5. Where does 6 go in this row? Has to go there. So that's a 6, 5, 5, 4. This is a 6 now with a 4 there. It's a 5, 6 pair, which is resolved. This is a 2, 4. This is a 4, 8 pair, which is resolved. That's a 1. That's a 3. This is a 1, 3. That is a 3 over here. And that's 3 in the corner. That's 3 in the spotlight, losing its religion. It's a 5, 9. 9, 8. 8's there. 6 is there. 2's there. 2, 7. Those are not 7 anymore. This is an 8. That's a 4. That's an 8. That's a 7. That's a 7. That's a 5. This is a 7. That's an 8. That's a 9. That's a 9. That's a 6. And then we just have 4 and 8 to go, which is placed. And there we go. Day 104, not bad. Alright, on to the next. 1428 Elm Street. Normal Sudoku rules apply. Thermo. Digits along the thermo increase from the bulb to the end. Whispers. Adjacent digits on a green or light brown line differ by at least 5. Renban. Each red line contains a set of consecutive digits in any order. Killer. Digits in a cage sum to the given total. Okay, and I've been through these rules before. I've played these games before! This is a thermo. Everything increases from bulb to tip. These are brown or green are German whisper lines, which means 1, 2, 3, 4, 5, 6, 7, 8, 9, alternating between them. And reds are consecutive run bands. Killers, of course, just means that the digits inside the cage add up to the number inside of it. Okay, let's get into it. 28 in 7 cells has to be 1 through 7, so this is 8, 9. This has to be 9, 5, or 8, 6, so there is a 8, 9 pair over here. That 9, 8 makes this a 7, 6, 5, 4. This is at least at most a 4. Also 9, 8, 7, 6, 5, 4 makes this at most 3. Actually. This has to contain a 9 and an 8, and then either it has 7, 4 adding up to 11, or 5, 6 adding up to 11. 9, 8, 7, 4, or 9, 8, 5, 6. Because digits alternate between high and low on a German whisper line, all of these will be either high or low, and these will be the other. These two cannot be 4 or 6, because otherwise both these would have to be either 1 or 9. So one of these is a 4 or a 6, making this a 1 or a 9. That means none of these can be 4 or 6, so they're either 1, 2, 3, or 7, 8, 9. They can't be a 4 or 6 because otherwise then that would be a 1, 9. One of these is a 5, and the other a 4 or 6 of the yellow type. If this is 1, 2, 3, or 7, 8, 9, that means this one has to be 2 or 8s. This is 1, 2, 3, that's a 9, which makes this an 8, because 8 is 5 away from 3, and it can't be 9. Or this is 7, 8, 9, making that a 1, and the 7 has to be next to a 2. If this is 1, 2, then one of these has to be 3 or 4. Making this at least a 2. And at most a 2. These red lines make this a 1, 2, 3, or 4. In fact, one of these, either one of these over here, or this one over here, is 3 or 4. Which makes the next one below it 2 or 3, which makes this one 1 or 2. Since that's 1, 2, or 3. But one of those is definitely a 2. Where does 8 or 9 go in this box? 9 can't go there. It could go here if that was a 1, 2. And then that would be 6, 7, 8. Or 7, 8 there. If this were a 7, this would be a 3, 4 pair. If it were 8, either 4, 1 or 3, 2. No, it had to be 4, 1. If it were 9, wait, no, if this were an 8, it would have to be 1, 5. If it were 9, this would have to be 1, 4. If instead this is a 1, 2, 3, then there are way more options. This is 4, 5, 6, or 7. 3, 4, 5, or 6. And 2, 3, 4, 5. This cannot be low. Because if this were low, then this one would also have to be low. This is 1, 2, 3, 4. This would also have to be 1, 2, 3, 4. But then there's 5, 1, 2, 3, 4s in this box, which is impossible. So this is a high, and these are low. This is a 1, a 2. That's 6, 7, 8, 9. This one, these are 6, 7, 8, 9 in fact. 7 goes with 3, 4. 8 goes with 1, 5. And 9 goes with 1, 4. This is not a 6. This could be a 6. This is 7, 8, 9. This is 6, 7, 8, 9. This is 1, 2, or 3. This is 2 or 3. This is 2, 3, 4, or 5. If this were a 3, it could still go here. It's a 2 there. This can't be a 2. Because if this were a 2, that'd be 1. And that'd be a 2 by random logic. And then there'd be 2 2s in the column. These can't be low. Both can't be low. One of them at least has to be high. Because otherwise, if they were both low, one of them would have to be a 4, seeing 2 9s that see each other. They both could be highs though, with 7, 8, 9 being both of them. Uh, 9, 1, 4, 8, 1, 5, 7, 3, 4. Or 1, 6, 2, 5. But not 2, 5. It also could be 1, 6, 7. Actually, no. You can't have both 4 and 3 over here. Because you have 4 and 3, the only thing below 4 and 3 is 2. So both of them would have to have a 2 below, which is impossible. So this is not... This one has to be 3 or 4. This is not an 8. Oh, that would be a 1, 5. It couldn't be a 2, 4. So either you have 9 with 1, 4, or 7 with 3, 4. And those two is an 8, which means that it's not an 8. Where does 1 go? Has to go over here in this box. So that's not a 1, which means this is a 7. Those are 8, 9. This is not a 9 anymore. 1, 5, 6. These are not 7 anymore. This is not a 7. Oopsie daisy. If that were a 1, that would be a 3. If that were a 2, that wouldn't be a 2. This is never a 2. Because there is 2 in both of those. You can see that much. One, 2, with a 2 there, see that? That's a 2. This is not 6, this is not 5. If this is a 2, then 2 is either up there or it's here. Well, 2 is either up there or in one of those two. 2's up there, that's a 3, 4, 5, 6. One of those two is 6. One of these could be a 6 or 7, but not both. The other one have to be 1, 3, or 4. Or they're both 1, 3, or 4. If this is a 1, that's a 2 and a 3. If this is a 1, that's 2, 3, making one of those 3. Otherwise, this is 3, so there's always a 3 over here. Not really worth much. I mean, we already knew that these are going to be 3s because it's 8, 9. Where does 7, 8, 9 go? In this box. We can have 1 over here. 1 over here and 1 over here. Or 2 over here. If not, this can't be 2 over here. If this was 8 and 9, meaning that is 7 and 6, then you can have 1, 8, 9 here. Then you have to have 2 over here. 7, 8, 9. 7 8s. They'd both have to have that 9 above it. It's impossible. So there is an 8, 9 over here. A 7, 8, 9 over here, and a 7, 8, 9 over here. So this is a 6. This isn't a 6. This isn't a 5. This isn't a 4. This is a 1, 2, 3 triple. There's a 2 beam over here. Seven, 8 over here with an 8, 9 up there. One of those is a 7. Do. This has a 3, 4, 5, 8, 9. 3, 4, 5 has to see a 2 below it. Because there's 1 over 3, 4, 5 here. It sees 3, 4, and 5. So the only thing below 3, 4, 5 is a 2. So there's a 2 here and a 1 there. Which makes this a 3 out of 2 out of 2. This is a 2 now. None of these are 2s. This is not a 3. This is a 3, 4, 5 triple. So that's not a 5. This is a 5. 1, 6 pair. That's not a 5. This is a 2, 7, 8 pair. With a 3, 4, 5, 8, 9. This is not a 1. This is not a 2. This one is a 2. This is a 3, 4, 5. That's not a 3, 4, 5. This is 6, 7, 8, or 9. Same with one of these over here. This is 1, 6, or 7, because it can't be 8 or 9. Where does 2 go in one of those two cells? Where does 1 go in this box? Can't go there. Goes in one of those two cells. Where does 1 go in this box? Can't go there. Goes in one of those two cells. It can't go there, so it has to go there. 1, 2. That's a 1. That's a 6. 3 does not go in there. Goes in one of these cells. 394 would be that one. 3, 8, or 9 would be that one. Seven, 4, 5, 6 in here. One is one of these cells, 2 is one of these cells. Two and 3 are one of those cells. These two cannot be a 2. Because if they were, they would need a 3 on them. But you can't have a 3 here or here because of this 3 over here. Oh wait, no, that's not a 3. There can be a 3 there. Never mind. If 2 is there, though, 7, 8, 9. The 1 there. Or, yeah, bunch of options. 2 is one of those 3. Makes that a 3. Either 5 is here, or it's in here with the 6. Where does 6 go? Can't go there. What could go there, actually? This is either a 3, 6, or a 7. 3 makes that a 4, makes that a 9. Or 6 or 7 makes that a 1. This is either 1, 3, 4, 6, or 7. Okay, there's a bunch of options there, not worth it. That's a 3, that's a 4. That's a 6 or 7, that's a 6, 8, or 9. That's a 3, that's a 4, 5. Hmm. 2 goes on one of those 2 cells. If one of those is a 2, one of those is a 3, then one of those is a 4, because that would be a 2, 7, that would be a 1. So it can be 1, 2, 3. That'd make that a 5. Which would make all of these a 6, 7, 8, or 9. This is either 1 or 4, or it's 8 or 9. 1, 4, 8, or 9. Forgot to update that. Whoops. One of these is a 3 or a 4, so the other one is 8 or 9. Ah, so this one cannot be 3 or 4. 1, 2. This one cannot be the low, otherwise they have to be 8 or 9 up here, which is impossible. So this is 3 or 4, and that's 8 or 9. And thus this one, which is a 1 and a 2 on both of these, cannot be 3, 4, it can't be lows. So that's a 6, 7, that's a 1. It's no longer a 1. It's 4, 8, or 9. This is a 9 or a 3, 4. Um, 7, 4. Nice out of 5. 5, 6. Nice out of 3, 4. This is 3, 4, or 5. This cannot be a high anymore, because this is 6, 7, 8, 9. If this was 8, 9, if this were a 6, 7, that'd be a 1 or a 2, but it sees both of them. This has to be 1, 2, 3, or 4. It's not 2. This has to be 2, 3, or 4. This has to be 7, 8, or 9. One of those two is a 1. It cannot be that one, because then that would be a 2. This 8 or 9 makes that an 8 or 9. And there's an 8, 9 pair there. The other 8, 9 goes over here somewhere. Seven, 4, or 5, 6. Can't be a 6 because that can't be a 5. Could be a 2, 3. Cannot be 3, 4. It can't be 1, 2 because there's 2 ones. It could be 2, 3. It can't be 3, 4 because that 3, 4. Could be 4, 5. Could be 5, 6. Could not be 6, 7. Could be 7, 8. Could not be 8, 9. None of these are a 7. One of those two is a 7. That's a 7, that's a 6, and that's a 5. Where does 5 go in this row? Can't go there, it's supposed to go in one of those two. So it's not a 5, it's not a 9. That's a 4 and that's a 3. Then that's a 4 and that's a 3. This has 6 8s. That's a 3 4 5. Ah, if this is a 3, then that's a 4 5, which makes that a 9. And that a 4, and it's 2 4s. So that's not a 3. This one is a 3. That's a 3, that's a 4. That's a 3. That's a 3. This one is 4 5 6 or 7. That's not a 7. None of these can be a 1 because that can't be a 2 or 3. So this one is the 1. One of these two is a 3. Which means there is a 4 on one of those lines. Because it can't be 1 2 3. Since this is not a 4. It's either 4 5 6 or 7 6 5. There's always a 6 there, so that's not a 6. That's not an 8. This is a 5. This could not be a 4 or a 6. It's impossible. This cannot be 1 2 3. It could be a 4. Cannot be a 5. Can be a 6. 7 or 9. 4 would make that a 3 or a 5. But it can't be 3, so it would have to be a 5. 6 would make it a 5 or a 7. Both work. 7 would make it an 8. 8 would make it a 7 or a 9. And 9 would make it an 8. What is next in this puzzle? Where does 6 go? Can't go there. Has to go on these lines. 6 can't go with the 3, 4. So it has to go on the other one. Could be... Well, actually, the 2 would go with the 3, 4. If the 3 was there, then what would it be? It would have to have a 4 on it, which would be over here. And we couldn't have a 2 on it, so we have to have a 5. 3, 4, 5. Ah, yes, that's it. If there's a 3 on one of those two, then I'd have to have a 4 on it. So that could be with that 3's 4. So I have to have like a 4 here. Like, say that's the 3 has a 4. And then it couldn't have a 2 now, because there's a 2 looking at it, so it has to have a 5 here. And this one now, 3, 4, has to either have 5 or 2. Looking at a 5, it has to have a 2. And now there are 2 and 3 over here, so this can't be anything. Which means that 3 goes over here. That's near 9. This is not a 3. This is not a 2. These two are a 2. So that's a 2 over here in that row. That's not a 1. This is a 1. One of those two is a 1. Wherever the 2 is where the 4 is. So that's not a 4. One of those two is a 4. We said a 5. This is not a 4 or a 5. 6 or 7. One, 2, 3, 4, 5. This is 6 or 7. 4, 6, 7. Yet again, 6 either goes with 7 eighths, 7 5, or 5 4. This is not a 2, this is 5 8 or 9. This is 4 5 6 or 7 over here. This is not a 6. If this is a 7, then that's a 4 5 pair, that's an 8 9 pair. That one can't be a 9, otherwise that'd be an 8 breaking that. So that'd have to be a 9. There's an 8 there and 7 there. This is either 4 7 or 5 6. Which means this is either 3, 4, 7, or 3, 6, because that's a 5. If it was a 4, it would go with 5 and a 6. If it were a 6, 7, it would have either a 5 or an 8. Ba-dum-bum. Ah, yes. Where is this 8 or 9? What is this 8 or 9? Let's give it all these colors. This 8 or 9 goes over here in this column, goes over here in this box, goes over here in this column. So where does it go? It's also over here. But where does it go in this box? If we look at the row, it can't be here, it can't be here. So it has to be one of those. If we look at the column, it can't be here, it can't be here. So it's one of those. The only overlap is that just right there. So that's an 8 or 9. Which makes this a 3 or a 4. That's one deduction, I guess. This is not a 9, we know that. I lived in a treehouse, landed in a cake, but I never saw the way the orange did the rake. Ah, the good old days of the internet. This is a 589 triple. This is 4, 6, or 7. Have you ever seen a llama kiss a llama on the llama, 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 duck? He goes here. This one definitely consists of 6, and this goes over here. So that's not a 6. This is 8 or 9, this is not an 8, therefore. This is 4, 5, 6, or 7. This 8 or 9 goes over here. Which means that this is 8, 7, and that's 9. This is a 6, it's a 5, this is a 4, 7, 8, 9. These are no longer 6. This is a 5. This is 4 or 6. This is 4, 5, or 7. These are no longer 5. This is 4, 5, or 7 as well. Not a 7 though. This is 2, 4, 5, or 6. But if this is a 6, that's a 7. Same for this. If these are 6s, then one of those is a 7, then what's the next digit? It can't be 8 or 5. So these ones can't be a 6. 6 is over here with the 4, which makes this a 7. This is 6. That's not 7 anymore. So this is a 7. These are not 4s. This is 5, 6, with either 7 or 4. This is a 4, 5, so that's a 7. That's a 4. This is an 8, 9 pair. That's a 9. That's an 8. 8, 9. These are no longer 8s. This is not a 9. This is a 4. This is a 4. This is a 5. This is a 6. It's a 5. That's an 8. This is a 4. That's a 5. This is 1, 6, 7, or 8. This is not 5 or 7. 4 or 6. This is a 4. This is a 3. This is an 8. That's a 7. This is no longer 7. That is an 8. This is a 1, 6 pair. That's a 9, 8, 9, 7. This is 6. That's a 1. That's a 1. This is a 2, 7 pair. Those are not 7s. This is a 5. This is a 4, 6 pair. This is a 3. That's a 3, 2, 4, 6, 5, 4, 7, 4, 6. This is a 6, 7, 2, 4, 7. There we go. Okay, one more, and I'm done for the night. Italian nightclub. Normal Sudoku rules apply. Digits in a cage sum to the given total. Clues outside the grid give us some of the digits between the 1 and the 9 in that row or column. Greater than means strictly greater than. Okay? So if you had a 1 and a 9 here, and that was a 2, 4, then this would be a 6 clue, which is greater than 5, so that would work. So that's an example of that. Okay, let's get into it. I've seen this arrangement of 9 cages before, and what you have to know about these is that there cannot be a 7, 8, or 9 in any of these cages. So where do they go in these rows? These columns. They have to go there. But now we have 7, 8, 9 triples in these rows and these columns. So where's the last place that they can go? Where to put them in there? In the middle as well. So now we have a bunch of 7, 8, 9s in the middle and in each of these boxes. We also know that in these 3 cages, there have to be 6 of the digits 1, 2, and 3. Each of them has to have 2 1, 2s, and 3s. So that means that 6 1, 2s, and 3s with 2 each would have 1 in these. So for example, if each of these has to have 2, there's at most 1 here, at most 1 here, at most 1 here, which means that is all 3 of those 1, 2, 3s. They need 3 more, and those have to go up here. And it's the same for the columns. Those have to be 1, 2, 3, and then the middles have to be 4, 5, 6. And now, oops, that was there. We have 1, 2, 3s in these rows and columns. So the rest have to be 4, 5, and 6. So all those are 5, 4, 5, 6. And then these have to be 1, 2, 3, the last of them. And let me just put all these blue, all these yellow, all these orange. Now, this greater than 20 clue. This cannot be done if these two are 9s. If this is a 9, where does it get its 1? It can't be there, that's at most 6. Can't be there, that's a 0. Can't be there, that's 8, 6, 3 at most, which is 17. If this is a 9 by similar logic, that's a 0, that's at most a 6. This, however, could be 11 plus 8 plus 3, which is 11 plus, that could happen. So these two could be 9. However, this one could not be 1. At most a 6, at most a 15. Oh wait, it's a 9. At most a 6, at most a 0. That can't be 9. One of those two is a 1. One of those two is a 9. That means that one of these is a 1. So this is not a 4. Hey, raid! Hello, everyone. Oh, Chinstrap, nice. Hey, Chinstrap. I'm almost done for the night because this is a very easy puzzle. It's the last of them. But I'll still chat afterwards. This one cannot be a 9 because that would be a 0. That would be at most 6, and that would be at most 6 plus 3 plus 9, which is 18. And this one cannot be a 1. That's at most 6. That is at most 14 plus 3 is 17. Yeah, I'm at 8 hours and 5 minutes now. Just doing 10 puzzles. Just a measly 10 puzzles is all. Can this be a 9? Yes, because that's all def. This is a 9, that's a 1. Where that's 9, that's a 1. The two possibilities there. If that's a 1, that's a 9. Yeah, I can get quite invested when I like something. Let's see. Full imposter challenge? Was that one of those the monthly hunts? What happens with these ones? That's a 1. And that's a 1. Which means that a 1. Maybe it has something to do with 9s and 1s together. One of those is a 9. That a 1. That a 1. "48 puzzles, that's nothing." No, I'm kidding. It's quite impressive, actually. 1, 9. If that's a 1, one of those is a 9. If that's a 1, then any of those are a 9. What's happening here? Face to face with greatness is strange. Well, this certainly is greatness. Can that be a 9 and that be a 1? Maybe that's it. If that's 9 and that's a 1, then this is at most 11. Plus 11 is 22. But it has to be greater than 22, which is impossible. There we go. That one cannot be a 9. Which makes that a 9. That a 9. That a 9. These are no longer 9s. One of those is a 9. Most likely we're going to have either this be a 9 and that a 1, or that 9 and that a 1. Now that this one cannot be a 1, so this one has to be a 1. These are no longer 1s. That's a 1, that's a 1. This is a 4. These are no longer 4s. These are not 1s. This cannot be a 9 anymore. So this one is a 9. That's not a 9. That's not a 9. So this one is, and that one is. This is a 9, and so is that, and so is that. And we're done with the 9s. This can't be 1 anymore, because that would be a 0. So this would be this, and that has to be a 6. These are no longer 6s. In fact, that is a 4. That's not a 4. That is that. This is a 1, that's a 1, that's a 1, that's a 4. That's a 1, that's a 1, and then we're done with 1s now. These are not 6s. Let's make this an A. And this a B. A will be with C, and B will be with D. These are not 4s anymore. These are not 4s anymore. C then. Oh, this is a 5. These are no longer 5s. B goes with D. So this is a C. That's a D. But we need that. What can this be? 8, 6, 5 is 11, 20, 3 is enough. Well, 11, 19, 22 is enough. But it's 1 degree of freedom. So if that were a 6, that'd be 5, 4, 9, 18, 17, plus 3 is 20. So that's not possible. It's not a 6. This is perfectly good to be greater than 22. Somehow, this has got to break the rest of the puzzle open. If this were a 4, and that is 6, this is 18, which means this has to be a 3. So how's that 6 and that's a 3? A would be 3, which would make D a 6. So that'd be that one, which is impossible. There we go. If this were a 4, then this would have to be 6 with an 8 and a 3. That makes that A a 3. So A is a 3, which means C a 5, which means D is 6. And now where's 6 in this row? Can't go there, there, it has to go there, but then that's seen by this one, which is impossible. So therefore, this is not a 4, this is a 6, which makes that a 5. That a 4, 6, 5, 4. C's are 6s, D's are 5s, A's are 2s, B's are 3s. Those are all done. This is a 4, that's a 6, it's a 5, it's a 4, 6, 4, 6, 5, 5. And then this is 11, plus 2 is 13, is 8 more. So this is an 8, that's a 7, and then we can finish this off. There we go. 1537. Nice. And that ends all the puzzles for today. Thank you. Thank you, Prime. Thank you, Skojo. It feels so nice doing this. Hey, Gwen. Welcome. Thank you for the GG. I thought those were a pair of eyes at first. Not gonna lie. Now I could do more. I have more in me, but I have to eat dinner. I haven't eaten dinner yet, so I need to go do that. And there's tacos downstairs that I have left there for a little bit. So yeah, thank you everyone for coming. It's been so great having everyone. True, tacos are important. It may not be a Tuesday. That may only be 2 days away, but tacos are still important. I will be streaming tomorrow, probably around 3 or 4-ish. Depends on when I get back from interviews tomorrow. But, yeah. If y'all wanna come join me then, I'll be probably there for like maybe 3, 4 hours tomorrow because I have gym tomorrow as well. But if not, thanks everyone for coming, and I'm gonna end stream now. Good night.